The interactive simulator, of course, can be done in minutes or seconds, which means you are forced into designing a lot of activity as a workflow online if you're going to keep students engaged for a window of time. And that forces you to hit them with higher levels of questions, the higher learning that I talked about earlier. And the whole challenge is one of how do you keep people busy for 5 to 15 minutes, which is now the equivalent of a lab session online, okay, compared to the 3 hours. So the 3 hours, if you think about it, in a fluid mechanics experiment or a heat transfer experiment in engineering, is because students are waiting for some steady state to arrive, some measurement to stabilize, and so on. And there's a lot of wasted time in between as they're sitting around waiting for something to happen. And you don't have that in an interactive simulated environment. So because the theory is already coded in the background, there are computations which happen immediately, and very quickly you arrive at some conclusions. So examples of the pre-test, forcing people to answer these things before they can move on to the simulator, giving them exposure to the theory itself, not assuming that they've read it somewhere else. Notice that this is very bare bones in terms of an interface. We're asking people to try different settings to generate different flow rates, and then from there, we later on require them to compute different things. So they start things, they watch these things. So this is an example of a lab experiment which is not a real world, realistic kind of thing. On the other hand, it is a very simple interface, and what the advantage of that is, this is accessible to students on even a phone, and it is not a heavy, bandwidth heavy kind of experience for a student. The phone thing becomes important because you've got to appreciate, especially in the time of the pandemic now, that a large number of students are trying to access content through a phone, and they're not at desktops, they're not necessarily at laptops. So some of the stats that the Virtual Labs program is seeing is that approximately 50% of access of Virtual Labs is via a phone, which means you've got to design user interfaces which are phone friendly, so that people can click buttons, do things, and collect data and so on, and then do further activities with this. So in this case, there are pressure drops being measured and computed, and flow measurements being computed, and so on. So that's a simple interactive experience as a standalone experiment. But then when you look at what teachers want a complete learning management system, which is something like a Moodle or a Coursera or an edX kind of interface. They need to find a way to integrate this into their curriculum, and ideally want it as a free tool. Over the years, what you realize is different instructors are using the interactive content in different ways. Some are directly replacing the physical labs, the afternoon labs, with a collection of virtual labs. Some have started incorporating virtual lab experiments into their Moodle theory courses itself. So as I said earlier, the best scenario is you teach somebody a little bit of theory and immediately ask them to play around with a virtual lab. So in which case the virtual lab should be accessible via Moodle itself, right next to where the student sees the theory video. So the MOOC, the concept of a MOOC itself is now changing into being a highly interactive experience where you see and learn theory, and then you immediately play around with an interactive simulator, and then you go back and learn even more theory, and you keep going this way. For all the people who are involved in using this content and creating new content, it is clear to us that their understanding of the topic improved dramatically. And the basic thing here is, if you're trying to keep people busy for 15 minutes and you're designing some activities which will keep them busy for 15 minutes, you're forced, when you're doing these things online, into teaching them some basic theory and then adding some advanced work elements, so that they're kept fully occupied, given that all of these computations are nearly instantaneous when they're done through a computer online. From a student's perspective, obviously, at IIT Bombay and later on the other colleges, students were extremely happy to just play around with computers and do lab experiments from a computer interface. Physical distances are no longer an issue, and the quality of learning has obviously improved. Most importantly, they managed to do this at their own speed and at their own time. And increasingly, several of them have gotten into a mode where they're evaluating their own learning skills. So the MHRD program for the last 10 years has involved 11 partners. It's led from a funding perspective by IIT Delhi, but essentially what happened is each of these 11 entities you see here broke off and created a zone around itself. That's simply because of logistical reasons, given that the mandate was that we create content, but also spread this content and understand the usage of this content. So IIT Bombay, of course, as you can imagine, is in charge of the Western region. Despite the fact that there are multiple partners in the program, the decision was made that everyone goes through a common front end. So students should not be confused with content coming out of different places. So there's a single login. All the content for the moment is free. And different developers therefore contribute into this common pool of content. Early on, so towards 2009-10, 10 labs were created or were mandated. We created more. We then got into a phase where we created many more simulators. Then the focus shifted from creating content to now asking how do colleges actually get down to using it. So the focus became outreach from 2014 onwards. But in parallel, more content needed to be created because obviously there were gaps in what was being created relative to the university syllabus. And of course, university syllabi vary across the country, so that's another challenge. 2018 onwards, in what is the current phase, and that's going to come to a close in March 2021, the focus has shifted, particularly in our region, to now asking how do you get communities to start creating material on their own. So given that several colleges are broadly familiar with the notion of a virtual lab and how to use a virtual lab, many of them then had been coming back to us and asking how do we create and solve our own content problems where we will create experiments for our own teaching purposes. So in other words, the pressure was on us to shift from being just the content developers and outreach managers to now helping other teams create content and solving their own problems. If you look at the disciplines, obviously virtual labs, when you think about it, are easy to create for the engineering and math kinds of disciplines. That's because at the core of it, you are playing around with the equations, you're doing some computations, and you're feeding some results back through a nice interface back to students. These things are slightly harder to do in the sciences per se, so bio and so on, because there's less math involved inherently. And there, the interactive experience is one of trying to explain protocols for various experiments and letting people through an interactive experience of what may happen if, for example, you change the order of steps in a protocol. So some of these things will be discussed, I'm sure, with you in the afternoon session as you learn the basics of how to create these things across various disciplines. Just to give you a sense of coverage, you can see that there's widespread coverage now because we broke up into the 11 separate zones and then tried to maximize outreach. There are gaps. You can still see there are gaps in the map, especially in the north and the northeast. And the mandate now is to try and fix those gaps. There are challenges, for example, with doing that. Jammu and Kashmir, for example, recently came to us. But as you probably are aware, Jammu and Kashmir is permitted only a 2G connectivity. So how do you run virtual labs using a 2G connectivity is itself a technical challenge. We at IIT Bombay have been focusing on a model where we partner with all the colleges around us and we create what are called nodal centers. And the nodal centers work with us first with using existing content and get their faculty members involved in using and becoming familiar with this content. And then steadily upgrading into creating their own content. So that's a model we have created. So we've got a very large number of nodal centers in our zone because there's been very enthusiastic usage of virtual labs in Maharashtra and Gujarat in particular. If you look at the overall counts nationwide, there are 700 colleges which are formally signed up. The mandate for nodal centers is you become familiar with the content created, you start creating new content, and you in turn become hubs which will help colleges around you into further spreading content. So it's a hub and spoke model that we are now looking at. You can see that the majority of the nodal centers are from our zone, 166 out of 700. So how do you become a nodal center? We have standardized these as processes, and these slides will be available to you later if you're looking for details on all of these as processes. So the basic intent is for colleges to become familiar with the content on the virtual labs platform and then submit a formal expression of interest. And because there's an issue of how we scale and coordinate and get things done, we end up preferring to work through a nodal coordinator at a college nominated by the college. And then that nodal coordinator handles the rollout of workshops for students across these colleges, and then in turn reaches out to neighboring colleges, and we periodically interact and review and facilitate the coordinators if they need any assistance. From a development perspective, the way to scale has been via bootcamps and workshops. That's because the challenge here is to work with large numbers of people and give them a sense of what is needed to create a good virtual lab experiment. And there are two things. One is you have to learn the best practices in terms of pedagogy. And then you also need to learn the best practices in terms of software and product development, because you're creating content which hopefully will be viable as code for a few years. And the problem with creating software is that things become obsolete rather quickly. So the challenge of how to create content and maintain it involves you playing around with certain standard software, especially if you later on also want the largest number of people to benefit from the content you've created. Just to give you a sense of what we do, we pull in highly motivated students into IIT Bombay as intern and ask them to help develop the content. This became so important to us as a program. We've gone off and created a standalone entity called VLabs Dev, which is just a development platform for instructors who want to come in and create content. And what we are starting to do there is just to fill it up with information about best practices and also find a way to find guidance from some of the content developers who already created content. This is also a place where codes will sit, and the whole intent is that this be open source. So it's a community portal driven by the community, and all we end up doing is curating the content and hosting it, where collectively we learn the best practices of how to create content, and we develop this and also propagate the usage of this newly developed content. Skip all this. The same slide that I put on the domains, but if you look at these numbers on the left, you'll realize that some of these are very poorly covered in terms of content coverage. And what it fundamentally means is that huge syllabus gaps still exist. And I think that was the point that was being referred to earlier, where we're all being encouraged to participate and create content, especially now, given that there's no other choice during the pandemic. And it's important here to appreciate that the IITs cannot create content for the universities, because the curriculum in the IITs is different from most universities. And there are many disciplines which we don't even have in the IITs. So there's no shortcut to this. So the colleges have to create their own content. And by the way, the colleges might take a particular learning objective. And as you know, each instructor has a certain teaching style. So for the same experiment, it might turn out there's a need to create multiple versions of the same interactive experience with different learning objectives ultimately in mind. So we need to scale the whole content creation process. And that broadly is the focus of the workshop for the day. We essentially teamed up with a few of our nodal centers and elevated them into being regional center. PVG is one. And we have got some participation from additional institutes in Mumbai, Aurangabad, Baroda, Delhi. And we are already at a phase where 110 experiments have been developed by the community in a very short window of time. 110 is relative to the 1,400 experiments created over 10 years. So this is the way to go. So the community coming forward to create content, learning what it takes to create content, and then solving its own problem is the way to go. And it's something that I would urge you to participate in and explore, not just today, but down the road, in trying to figure out what you need. And we will be there to help you along the way. So just putting up some list of the names of the experiments which we have created. That you can see they are typically in the computer science and electronics area, but we have things in the physics and biology domains as well. We've been running workshops and boot camps, and that's simply because it's easier for us to, rather than hold several events online one after another, it's easier to pull a bunch of people together at one place and get them to focus and concentrate, especially when it comes to creating content. So there's now a process where there's a high energy kind of event where a number of faculty and students are brought together to try and brainstorm and then create content. So we've done this at several places, including one recently at UP. But the most recent one, in fact, is a bootcamp that we've run through the lockdown. So which I list at the top. So we've well, let me, yeah, so it's over here. We've run an event to the lockdown and attempted to create a large amount of content, given that anyway faculty and students during the early part of the lockdown had time on their hands to sit and look at encoding some of the theory as interactive simulators. There's a team of instructors which have steadily evolved, and I need to acknowledge them because these are people who have given a large fraction of their time towards helping others create content. And so they're turning into a group of mentors in the content creation process. Lots of students have also devoted a lot of time, and that's something else that we have come to realize. We really need to be harnessing the energy that the students have in creating this content, and it's about mentorship, telling them what to do, and usually they go and do a great job of it. There are two tracks now of how we do this. One is before the boot camps happen, we spend time with the faculty in webinar mode, bringing them up to speed on the basics of pedagogy and how to essentially, like like you would in creating a movie, you need to create storyboards. So you literally have to force people to visualize what the activities inside a virtual lab, and you create storyboards, and then you get them to essentially put down their thoughts, and from there convert it into small tasks which involve coding. Then separately, we work with the students to bring them up to speed on all the technologies which might be relevant for creating interactive simulators. For example, if you're creating a highly interactive animated content, then you need to be familiar with HTML5. We ideally want things access to browsers as content, and so JavaScript and TypeScript become important. Then you start putting all of these together, the faculty and the students. And the way it works, you don't necessarily put together students from one department in here. What you want is diversity of skill sets in a team. So the faculty could be from, let's say, chemical engineering, but the students could be from computer science and so on. Maybe you have one or two students from chemical engineering as well. But between them, they have enough skill sets to put down the theory of what has to be created. And they also have the coding skills, whether it be the browser user interface or whether it is the backend simulator itself for evaluating the theory online. And we then get into figuring out how to evaluate students online, because one of the challenges here, as you can imagine, is how do you grade people who are doing virtual labs. There are challenges also with how to make sure your content can be hosted with the least amount of trouble, because there are different ways people want it hosted. Some people want it running off a central server on a cloud. Some people want it running on a college server. And some people are happy with downloading the code and running it on local software. So in the bootcamp, we had a large an effort to reach out to a large number of participants across a large number of cities. And in some ways, this is the way to go. The usage stats for virtual labs, as you can imagine, and MHRD has been very curious about this. It's gone through the roof during the pandemic with large numbers of people, including international visits, because nowhere in the world has there been this quantum of content creation. In fact, we even had the Chinese come in and try to access the virtual labs content created through the MHRD program. We have a lot of content which is housed on a platform called Git, and the idea is this is an open source code maintenance platform. And the idea is, as people create virtual lab content, the next team which comes along to create content should not have to learn everything from scratch. Maybe you can borrow bits and pieces of code and bring them into your own experiment design. That improves the thing for the whole community. That speeds up development for the whole community. So we've been working on creating platforms for code maintenance and development. So there's a certain process for how content that's been created goes national. So there's, at this point, hopefully you're clear that there are two programs afoot. There is Virtual Labs, which is the content already created by the IITs and already available for use. And then there's a new content being developed. We're calling that VLab Dev. So when new content gets created, it doesn't automatically become accessible to the entire community. We actually take it through a review process very systematically through peer reviewers and then domain reviewers in particular. And once we're convinced that the theory is all correct and that the basic bugs have been pulled out, we are in a position to now go host the content online. And one of the major advantages for a college to do this is you get international visibility because you get branding of the content that you create. The only insistence we have is that this all be free and open source to the student to use. The team structure that I talked about, the faculty with students of different disciplines and so on. And the process has been refined so that we are able to condense it down, given that people have a lot of demands on their time. So there's a lot of effort where we train people in advance on various things through webinar mode. And then when a physical event happens, it's done typically over a period of 4 to 5 days, where we get down to the creation of content as opposed to teaching them the basics of content creation. And we even try to get a review of the content developed happening in real time, so that there's real-time feedback to the teams. And we have started the certifying teams which are creating these things. So we're looking at different models of fast tracking these things, getting colleges to fund their own content creation bootcamps, looking at the universities to get engaged in mandating the usage of this. As was implied earlier, AICTE is going to mandate that 20% of lab experiments be now done virtually. And this will continue post the lockdown itself. So looking at how to bring out better labs, and the moment you create a lab, there are ideas of improving the pedagogy, improving the user experience. It's like creating a video game. You create one thing, then students in particular are looking for the next most challenging thing to do. So how do you improve the level of content and get more and more people engaged? There's more emphasis on the bootcamp sessions itself and on certification of developers and on the review. You'll find a lot of this detail at these links, which I'll just quickly flash through, but you'll be able to access this from the slides that I'll leave behind for use later. Where is the Virtual Labs program going? We're looking at an open platform for a large number of developers to contribute, and looking at doing more of these events nationally. Technology-wise, we are trying to do this entirely through browser and cloud-based simulation, and the phone becomes an important user interface. And we are trying to build technologies which will allow for this to integrate into a MOOC platform. So Moodle is not designed for use of virtual labs. So at IIT Bombay, we have been investing through the data center that I run on a platform called Bodhi, which is a Moodle replacement. And we hope to find or build the functionality to integrate virtual labs into the Bodhi framework, so that students can go back and forth between theory and interactive simulators. There's going to be improved functionality in terms of authentication of students and validating it's the right student taking the experiment. That's because evaluation becomes critical down the road. How do you get people to start an experiment, pause it, go do something else, come back and resume the experiment? How do you have persistence in this? And we're trying to build in functionalization. And how do you make sure that no two students back-to-back get the same virtual lab user experience? Because then, for example, when you're grading them, they're just going to cheat. So how do you therefore randomize the various computations that they are going to have to do? And how do you give them different settings, random settings, and force them into doing slightly different experiments, so that each student has their own unique experience? We're looking at incorporating the best pedagogical practices and frameworks for creation of storyboards. And you'll hear more about this. There was brief mention about augmented reality by the VC earlier. We're looking at that, but that's at the high end of the spectrum, because that's very intensive in terms of what it takes for a student to experience. But the other thing that can be done is, as more and more students take virtual labs, we start learning a lot from the analytics. So for example, the way a strong student takes a virtual lab is different from the way a weak student takes a virtual lab. A weak student goes back and forth, for example, looking at the theory, coming back and trying something on the simulator, and they waste a lot of time. And if you just simply start paying attention to the time they're taking on an activity, you start learning whether somebody is going down the right track or not. And what that means is you can actually personalize the lab experience to a student. And we're playing around with these as features. You can actually give hints to students as they start taking an experiment, and you see them start to struggle. And you don't need a teaching assistant online to tell them to do this in real time. We hope to create more regional centers and recruit more nodal centers, so that helps with the further rollout effort and run more events. And we also expect to start creating content for polytechnic colleges and for the science colleges. A last thought on this. At IIT Bombay, we started with rollout. We focused on the creation of new simulator labs. We are shifting focus back to the creation of hardware labs as well, because at the end of the day, you cannot be teaching a generation of students on how to understand stuff through just simulators. They ought to see the real thing at some point. So how do you get them to now look at real apparatus, and how do you design experiences around the real apparatus? And therefore, how do you create low-cost hardware experiments that they can play around with? That's the next generation of things that we hope to engage with. And many of the kids who get into building their own hardware immediately get excited to work with us on innovation challenges. So we have realized that the reason to get into virtual labs is not simply teaching, but that in the longer term, there's so many great things we can do with the talent that we have around us. Just to give you the connect details at IIT Bombay, do get in touch with us if you wish to learn more about the virtual labs and the VLabs dev effort. And the organizers of this event will obviously also be accessible to you if you wish to learn more. So I'll pause there, and I'll end with thanking a set of people. At Pune University, I thank Professors Karmalkar, Bormane, and Chaskar. At PVG, Professors Kaduskar and Kulkarni, and Professors Katafkar and Nagoshe, who have been running virtual labs at PVG. At AISSMS, there's Professors Bormane and Balke, who have been helping put together today's program. And at IIT Bombay, the program is dependent on Pushpadeep Mishra, who's the program manager, and you'll interact with him later on in the afternoon. So I thank all of you for coming online and for participating in this activity today. And I wish you the best as you engage in learning more things throughout the day. So thank you for your attention.
Thank you, sir. Thank you so much for giving good insight on VLabs and how it is going to help students, as VLabs give very realistic practical experience, and also how all engineering discipline students will be benefited by this VLab. I extend my gratitude on behalf of AISSMS College of Engineering and PVG's COET for sharing your valuable time with us. Thank you, sir. Now, I would like to introduce Mr. Kaduskar Rajendra Gopal, Director, PVG and PVJ's COET Pune. He has 32 years of experience. He has 15 number of publications in National Journal, 8 in International, and 5 in IEEE journals. He has 1 teaching award and 3 special recognition received, 9 number of books published, and 1 monograph. We welcome you, sir, for this session, and I request you to share your thoughts with us. Thank you. Hello, sir.
Hello, sir. Kaduskar, sir.
Sir, I think he's not.
Yeah. Is it okay? Yeah.
Yeah, you are audible.
Yeah.
Yes, sir.
Good morning to all. All the dignitaries present for the today's workshop, eminent scholars, professors, distinguished principals, chairman board of studies of different engineering disciplines, and faculty participants. We are fortunate to have today with us the chief guest, Honorable Vice Chancellor of Savitribai Phule University, respected Dr. Nitin Karmarkar, who already gave us an address, and he spelled out the expectations and challenges of future education. Also, I would like to welcome guest of honor, respected Dr. M.G. Chaskar, who is Honorable Dean, Faculty of Science and Technology, Savitribai Phule University, showing a keen interest in this activity, and probably it is with an hope that he will promote this activity further. Even I would like to welcome Dr. Santosh Narona, Honorable Principal Investigator, Virtual Labs, IIT Bombay. Respected Dr. D.S. Bormane, Honorable Principal of AISSMS College of Engineering, Pune, and Chairman of Board of Studies, ENTC, who already initiated this activity and started to introduce this VLab course in the syllabus. I, Professor R.G. Kaduskar, on behalf of PVG COET, VLab Nodal Center, extend my warm welcome to you all for the today's workshop, which is being conducted online due to the present COVID-19 pandemic situation. As you are all aware that for maybe last half an hour, Professor Dr. Santosh Narona from the Principal Investigator, Virtual Labs, IIT Bombay, explain how the progressed and what are the different activities are going on and which activities being run. Now my role is what's the role of PVG COET, because in the slides you might have seen that PVG COET faculties and the students are being observed in the screen and the development being done by PVG COET. As an opportunity and support from IIT Bombay, PVG COET become the part of this particular activity and establish a Nodal Center on 9th March 2015. Knowing the work task, we requested IIT Bombay that we should have two coordinators. One is for the normal content development and one is for the technical, and they accept our request, and the two senior faculties, Professor Mrs. Tanuja Kataukar and Professor Manish Nagoshe, been given the responsibilities as nodal coordinator and nodal technical coordinator. With the initial planning, discussion, debate, the various execution aspects, the knowledge sharing between IIT Bombay and PVG COET faculties, it was possible to conduct some of the outreach workshops in the initial phase. After realizing the need of expanding the team of PVG for further tasks, we strengthened our team by adding the nodal center coordinators from the department wise and even the technical coordinators department wise. And this new team developed the content which is involve the students and inculcate the essence of virtual lab project activity amongst them. They are also giving training to the new pool of students, content development. So all that has been because of the efforts of PVG COET, VLab Nodal Center took that. And with a continuous encouragement and support of IIT Bombay, the team with a dedicated efforts and great teamwork developed in the initial phase around 14 plus subjects virtual laboratories having more than 125 experiments in all and deployed successfully with the help of IIT Bombay. Recognizing the effort and contribution, IIT Bombay promoted PVG COET Virtual Lab Nodal Center to a Nodal Center regional on June 15, 2017. And I think Professor Dr. Narona has already mentioned that how the PVG COET has advanced from a nodal center to the regional nodal center. And today we are in the role of the regional nodal center. Indeed, it's a big opportunity for all our team, but it is the same time that it is to be and to work harder and that to be on a larger scale. And we, the Pune Vidyarthi having the organization in Maharashtra, more than 111 years of legacy in education social field, we always promote such type of activities which are of a social benefit and important to the society. And with the commitment and expectations of society, we always encourage the team and the faculty to contribute actively. So we keep that momentum, and really the PVG COT VLab team did excellent work, and they are also taken a role in introducing audit course on virtual lab development in Savitribai Phule University engineering curriculum, and this was started from the academic year 2018-19 for second year to final year engineering students of all branches. And I think the Savitribai Phule University, with the initiative of Dr. D.S. Bormane as the chairman board of studies, and with the presence of Dean Science and Technology, Dr. Chaskar, I think this activity will move further in the Savitribai Phule University and will be more effectively used in further curricula. I think our faculty, which is being doing for last 5 years a fantastic job, I am sure that they will show this their activity there by the way of presenting themselves and giving training in the today's workshop. And I am confident that the faculty in the academics will get the proper inside view of virtual lab, how it can be useful in the academics so as to improve the further teaching learning process. With this word, I give my best wishes to organizing team for all the success in today's workshop with an appeal to all, stay safe, stay protected. I once again welcome you on behalf of PVG Nodal Center. Thank you.
Thank you, sir, for sharing your valuable thoughts behind this workshop. and also how VLab has benefited students in PVG's COET. On behalf of AISSMS College of Engineering, I'm thankful to you for sharing your valuable thoughts with us. I take an opportunity to introduce Dr. M.G. Chaskar, Dean, Science and Technology, SPPU Pune. Dr. M.G. Chaskar is a fellow of prestigious academy, Mombisho Fellowship, Government of Japan, VBL Fellowship, Government of Japan, Visiting Scientist, Japan, Visiting Scientist, Germany, Postdoctoral Fellowship, Nagoya University, Hanover University, Germany. He has number of professional achievements. Few I would like to mention here. His member subcommittee of sports, University of Pune, as an observer under CAS, Amritsar, Japan. Member NAT peer team, Bangalore. Member BOS chemistry, Pune University. Member BOE SPPU. His member engineering faculty, Pune University. Member Senate SPPU. Member Management Council, SPPU, Dean Science and Technology, SPPU. He is recipient of Young Scientist Award, Best Paper Presentation Award, Babu Ravji Gholap Award by PDEA. Awards received by institute under his leadership are Best College Award by University of Pune, First Prize on University level and district level, Jagar Janivancha under University of Pune. His research publication include 23 international publication in peer-reviewed international journals in the area of solid-state material sciences, photocatalysis, one paper in top 25 in Science Direct list, year 2011. He has 3 major research projects completed as a principal investigator, funds received from UGC and Pune University, total individual grant received rupees 17 lakhs. He has 31 national and international level conferences attended, organized 10 conferences. We welcome you, sir, for this session, and I request you to guide all the participants. Hello, sir.
Madam, I think sir has certain technical issues. Bormani sir? Hello? Bormani sir? Hello?
Hello.
Sir, Chaskar sir is not there in meeting.
Just le
Participant, please wait. Due to some technical issue, sir is not there in the meeting. Please wait for some time. So till then, Katagar madam, you can just ask for the further process. Just I am contacting Chaskar sir in 1 or 2 minutes, please.
Okay, sir. Okay. Yes, in the meantime, I would like to take this opportunity on behalf of regional team of Virtual Labs from PVG's College of Engineering and Technology. By the time Sir joins, and we have a vote of thanks after that, we have a next session, that is the actual proceedings of our Virtual Lab workshop. Okay, so what we shall do is, after this inauguration ceremony, let us say we take a break of 5 minutes, okay, and we join back again and we have the actual session, that is the hands-on session, because we had a very good thorough idea of what virtual labs are, what is the objective of it. And now let us go ahead and see how we could use these virtual labs. So for that, what we have planned for the day is, in the next proceedings, we'll start with demonstration of virtual labs. So faculty from PVG COET, they would try to show or demonstrate at least one experiment from different disciplines. Okay, we have tried to address different disciplines, and at least one or two experiments, they would be demonstrating it to you. And virtual labs being the ICT tool, which is useful for self-learning. It's a you can learn on your own by looking at the virtual lab concept. If you'll appreciate that later, they will help you to understand by demonstrating the virtual labs. So following that, yes, we are going to have a hands-on session and online feedback as well. Okay, so you'll be provided time. We'll be there online, solving your queries through different mechanisms, which we'll explain later. So we'll have a hands-on session. And following that, we'll have, let us say, 2 brief talks about virtual labs from myself, that is Professor Tanuja Khataukar and Professor Manish Nagoshe. And then the most awaited, again, the keynote address from Honorable Pushpadeep Mishra sir, who is a project manager, virtual labs at IIT Bombay. Now the sessions are going to be, after the session, we'll have up to 12:30, we'll have some demo rounds. And the afternoon session will start around 2:30, and we'll have the next session, the next agenda that I have explained right now. Okay, at the end, we may have participants' experience sharing, and later I would request Dr. Bhalke sir to conclude the session and give the vote of thanks. This is what we have planned for the day, and we'll try to address your queries, okay, through, let us say, Google Forms and online. We'll try to help you out to understand how to use virtual laboratories. Mavli sir, do we have Honorable Chaskar sir with us?
Madam, just 2 minutes, sir is contacting. Then.
Okay, okay. So when the faculty from PVG COET team would be demonstrating, they are going to show you a sample case, one experiment. They will try to show you how to explore, and even they'll give you certain ideas or let us say tips as to how it could be evaluated online, because now we are at home, students are at home. So how do we do the evaluation or assessment of whether the student has genuinely done it or not? Now, every teacher out here can use their own methodologies to assess or do the assessment part of it. And a few tips would be given by our faculty, how they have been doing it. Or rather, you'll find these days, the new labs that have evolved, they really cater to even the assessment part. They also provide the grades to the student. And as Dr. Santosh Narana rightly mentioned, there is randomization as well included in certain virtual labs. These virtual labs have been developed right from 2009 onwards. So you'll find different flavors of similar type of experiments also. So it's the teacher who can identify which are the best of the experiments. They can give it to the students and ask the students to learn from these experiments. And this being you can say free of cost tool, every teacher, every student can use it at any point of time and from anywhere. So in the today's sessions, we'll have, as I mentioned, demonstration and then hands-on, and then we'll have few talks and a key address from Pushpadeep Mishra sir, and then we'll conclude the session. Over to you, Bhalke sir.
Madam, just sir said we will wait for 1 minute.
Okay.
Then we will have vote of thanks.
Okay.
Sir said to wait
Okay,
for 1
sir.
minute.
Okay.
1 minute.
Fine.
Madam, there is one query from the participant. They have asked in the chat box. Shall I ask so that Naruna sir will answer that question?
Do we have Naruna sir? Because sir was supposed to host a
Okay,
meeting
okay.
and he was not available, I
Okay,
suppose.
you are
Yeah.
Nagoshe sir can take. Meanwhile, I will
Yes,
just
sir.
go through the question. Shall I?
Yes, sir.
Yeah, go ahead.
Sir, in VLab, whatever simulator is given, it is 32-bit. Hence, latest system is not supporting 32-bit version. So, sir, if it is possible that 64-bit version also should be given in VLab, then it will be more useful. I tried with my students with 32 bits, but not success. So please guide us.
Yeah, so basically, new labs, what we are talking about is system independent.
Okay.
So meaning of that is just browser is will be needing, nothing else. So if you have any kind of browser, it will run on mobile as well as
Nagoshe sir, you're not audible.
Yeah, yeah. So there is a electricity problem at my end. Okay. So is I'm audible now?
Yes, you're
Yeah,
audible.
you are audible, sir.
Okay. So basically, we are targeting all open source technologies. You might have seen that we are using HTML5, CSS3, and JavaScript, and that doesn't require any kind of dependency. All the browsers basically understands HTML5, CSS3, JavaScript, or the TypeScript. So what are the labs are coming now? They have a lot of randomization with very high cognitive levels, which are totally system independent. So whether you are using mobile, tab, iOS, Linux, Windows, it's not going to make a difference. Yeah, obviously, when the development has started in the beginning, many people doesn't have a view how to go about it. So they started from some platform and started developing and building, and then they come up with some pilot stuff, all the stuff. So those are all older labs. So wherever you might be requiring some kind of JRE 32-bit or maybe JRE 64-bit. Okay, so that's the old technology that's already there, and then the massive conversion task is also going on all across India for all older labs. So those who are facing this such kind of problems, I would like to tell you that those problems will be dictated as early as possible as the massive content development is going on. So I hope that answered the query. So newer labs, whatever is coming, it's just a browser base. You need a one sort of browser, nothing else. So we are targeting even mobile frameworks also. So it will be working on mobile. So you don't need. We started developing on 2G network. So we have to also take cater to that technology also. That how we can use the minimum bandwidth, optimization of the code, minimal use of UI challenges. So all those stuffs are there, and more. What are the additional things are getting introduced is the high cognitive level and the randomization, and that posing a lot of technical challenges. Yes, there are solutions. We are trying our best. Hope with IIT Bombay will be delivering a few good labs soon. Thank you.
Malki sir, Bormani sir is
Yes,
saying
sir.
you can start the session, which will have the vote of thanks after that. If sir is joining, he will address us and then we'll have a vote of thanks. So, Khatagor madam can start the session.
Okay, sir. Okay. So this is what I was mentioning earlier. This is the agenda for the day, and that we are going to start with the sessions. What we have decided is that since Naruna sir has given us an insight of virtual laboratories, we will start directly with the hands-on session for which you people have joined today. Okay, because that's the major objective of the day, that you need to understand how to use these virtual labs and where to find these virtual labs. Teams PVG COET has also prepared, has made an effort, in preparing a document wherein we have tried to map most of the subjects from different disciplines of, computers, IT, or you can say applied science, mathematics, and so on, with the virtual labs that exist. So during the hands-on session, we shall also share this with you. So that's one of the takeaways. Hands-on session is one of the takeaways. And you'll also have the list with you so that when you go back, you can use this list and access the virtual laboratories and help your students to learn better. So the objective of this workshop is to empower the teaching fraternity with this ICT tool that would really enrich the teaching learning process. That's the actual aim. And now to start with the sessions on demonstration of virtual labs, I'll request Professor Meenal Apsangi, who is a nodal coordinator for PVG's College of Engineering and Technology, to take over this session. And please do the comparing. Meenal ma'am.
Yes, thank you, ma'am. Am I audible?
Yes, ma'am, you are audible. If you would like to share the screen, you can share the screen, right?
Yes, sure. Good afternoon, all. And I'm Professor Mrs. Meenal Apsangi. I'm a nodal coordinator of PVG COET from last 3 years. And welcome to you all for this much awaited hands-on session. So to start with our hands-on session, we'll start with a session from physics lab or physics discipline. So today, Professor Ranjita Ghosh, who is having 10 plus year of experience, and she has done her MSc in physics. She is a virtual lab coordinator for the first year, that is applied science department in our college. So now she'll explain you how to go about the physics related labs in virtual labs. Ghosh, madam.
Good morning, everyone. I am Ranjita Ghosh from PVG's College of Engineering and Technology. Today, I'm going to explain you an experiment on physics. Now, experiment on physics, how to do the experiment online by using the virtual lab. Basically, we are going to see that. There are 6 to 7 experiments of physics which we can map with the VLab platform. Out of them, I am going to explain you one. Now let us see how to go for it. Let me share the screen. Yes. First, we need to click on, we need to go on vlab.iitb.ac.in. Once you write this on the URL tab, you will come to this link. Now here you can see there are a lot of discipline. Now out of this, for physics experiment, we need to explore here the physical science. Now in this physical science lab, now you can see there are almost 12 labs, and each lab there are 8 to 10 experiments. So today I'm going to demonstrate an experiment based on solid state physics lab. So I have just clicked on solid state physics virtual lab. Now out of these, you can see there are so many experiments on that. Today we will see the demonstration of Hall effect experiment. So I'm just going to click on this. Now you can see the various tabs on the screen. Now this lab is created by Amrita University. So by virtue of Amrita University, this lab is available to us. Now let us explore this lab. Now the first tab is theory. Now in this tab, you can see the detail of all this experiment, the aim, the apparatus, and theory regarding this experiment. In very detail, it has been explained here. Now, the student must be asked to read this theory carefully so that they can able to understand the concept regarding this experiment. Now we need to go to the next tab, that is the procedure. So once you click to the next tab, you will see the procedure in detail. So now here in this experiment, basically, there are two parts of the experiment. Now in the first part of the procedure, we need to correlate the magnetic field and the current. Now from this particular part, we will come to know the value of the magnetic field when some particular value of current is being applied. So from the first part, we will come to know the value of the magnetic field that we are going to use in the second part of the experiment. Now in the second part, basically we will try to perform the experiment to find out the charge density. Now you can see the third tab here, that is self-evaluation tab. Now in the self-evaluation tab, there are 5 questions. Basically, these are related to the theory which has been explained earlier. So students are required to read the theory carefully so that they can able to answer this question. Now see what happens if I click the answer. So I'm just randomly selecting the answer here. Once I select the answer and click the submit button, it will assess my answer. So you can see all the correct answers here. The right sign is there. And for the wrong answer, there is a cross sign. That means this answer is wrong. Okay, students are supposed to evaluate themselves by doing this. So this is a small evaluation that can be done by this VLab platform by itself. Now later on, the next part where we are going to perform the experiment, that is on simulator. So once you click the simulator, it will ask for login. And then we need to click the login. And then you can log in through your Google account or the Gmail account. So you can log in through your Google account, click the password over there. Once you click the password, once you write the password, you can be able to access this. Now the simulator is open. So now you can see the apparatus, the virtual apparatus is visible over here. So as I earlier said, there are 2 parts of the experiment. In the first part, we have to find out the magnetic field related to the current. So you can see the first part, the part you can select it from the first drop-down menu where you can see it is written as magnetic field versus current. So this is the first part. Now the second part will be Hall effect setup. So first we will perform the first part. So I just click on magnetic field versus current. Then the next button I have to click, that is insert probe. So once I insert probe, you can see the probe is visible here and there is a message pop up here, that is click on the wood. Once I click on the wood, this probe started acting. Now there is a slider, say current. Now this current is regarding to the current through the solar. So now if I move this, the current will be changing here and it can be seen from this emitter on the setup. Now as you change this current, you can see here the Gauss meter reading is changed. So in the first part of the experiment, we need to note down the value of the Gauss meter reading, because in the second part, we are not going to read this reading. So in the first part, I can see that for 1 ampere of current, the Gauss meter reading is 0.1482. So we need to write it somewhere. Now we can perform this experiment for a different value of the current. So whatever current value you want to perform the experiment, for that you just note down the Gauss meter reading. So for 2 ampere of current, it is 2964. Likewise, for 3 ampere, it is 0.4447. So you just write this reading somewhere else so that when the next part of the experiment, when you change this current, accordingly, you can put this value on the observation table below. Now, this is the first part of the experiment. Now, let us go to the second part of the experiment. So when we go to the second part of the experiment, we need to go again for the first drop-down menu. Here, we need to select Hall effect. Now, again, we need to click here, insert the probe. Once you click the insert the probe, again, the same message will pop up. So you just click on here so that the experiment are on starting mode. Now you can see here the current is 1 ampere. So we have already written the Gauss meter reading regarding this, and that we can put it here in the column. You can see there is a Gauss meter reading column here. So I can write it as 0.1482. So this is the Gauss meter reading from the first part of the experiment. Now in the second part, now we can choose the material. Now let us see what are the variation available here. So germanium, aluminum, copper, gold. For whichever component or whichever material you want to try to do this experiment, try to calculate the density, you can click on that material. Then there is a variation of thickness. So with the help of this slider, you can vary the thickness and correspondingly you can take the reading. Okay, so I am doing the first part or the first experiment, first set of reading with the thickness 0.001. So I'm just going to write it as here. Now, and the next, I can see the Hall current is 1 milliampere. Now in this setup, you can see this is an instrument which is showing you the current as well as voltage. Now you can see that milliampere LED is open. That means this is acting now as a emitter. Okay, now the emitter reading will give you 1. So I can write here, Hall current is 1 milliampere already taken here. Now for showing the voltage through this device, I need to click here on show voltage. So now here you can see the voltage is being seen. So I just write down this voltage here. So this is about 28.756. So once I write this value of the voltage, now you can get the Hall coefficient for this material and as well as the carrier concentration of this material. So now in this experiment, we can see there are 3 variables: current, thickness, and Hall current. So with the help of these 3 variables, we can do the different variations of the experiment and you can give the student different type of experiment. Now, this is what is the experiment part. Now you can change the thickness. Again, you can perform the experiment, or you can change the value of the current and perform the experiment, and you can see the different set of the experiment over here or different set of value over here, and you can compare how the change in current will affect the value, how the change in thickness will affect the value, and how the change in magnetic field will affect the value of the Hall coefficient and carrier concentration. Now let us go to the next tab. This is the assignment tab. Now this assignment, there are 5 questions over here regarding the experiment that just now we have seen. Student can perform the experiment, and after performing the experiment, they can explain it very nicely. Now the next part is the reference. From this reference, they will come to know more information regarding this experiment. Now, to evaluate this experiment, you can create a Google Sheet, something like this. Now in this Google Sheet, you can frame your own questions, and this Google Sheet you can circulate to your student via your or through your Google Classroom. The evaluation of this Google Sheet can be done and grading will be saved in your Google Classroom. And at the end, when after performing all the experiment that you are going to conduct through the VLab, the grading will be done and final assessment will be done. So now you can see how can we do. So this is a sample allotment sheet. Allotment sheet, just now I said that for this experiment, there are 3 variables. The material is a variable, the solenoid current is a variable, thickness is a variable, and current is a variable. So with all these variable, you can give different set of variable to the student to perform the experiment so that you can get a variety of result for the comparison. Now in the next question, you can ask something like that. What is the value of solenoid current for which you have done the experiment? What is the Gauss meter reading? And here also you can write some question, something like, what is the effect of increase in the Hall current on Hall voltage? So whatever question you feel like asking, you can write it here and post it through the Google Classroom, and it will be evaluated by its own, and grades will be given in your Google Classroom. Not only given, but it is saved over there as an evaluation. So this is how you can conduct the experiment. Now this is all about. Now here you can see there is a last tab, that is feedback. We need not to explore this tab. The feedback regarding the online feedback regarding this experiment or all the VLab experiment will be later explained by Meenal Apsangi madam. That's all about this experiment. Thank you. Over to Meenal madam.
Thank you, Ghosh Madam. Thank you for that wonderful explanation of one experiment from the physics. Bhalke sir, can we go ahead with the hands-on session, or do we have Honorable Dean sir available with us?
Now, madam, I think Dean sir is not joining because of some technical problem. So as I think Khatawkar madam will see. So madam, shall we go ahead or we can do vote of thanks and we'll
I
start
think
session?
Valke sir, what I feel is it's around 12:30 as we had decided. 12:30 would be up to 12:30. We should have the first session so that people have the lunch. Okay. So we'll have a
Then
vote
we
of
will have
thanks.
yeah, madam. Yeah. I think Kulkarni madam is going to give vote of.
Yeah. May I request our principal, Honorable Principal, Dr. Kalyani Kulkarni ma'am, to express the vote of thanks.
Hello.
Yes, ma'am, you're audible.
Am I audible? Yeah.
Yeah, madam, you are audible.
Yes, thank you, sir. Good afternoon, all. Respected dignitaries, invitees, participants, and the host teams. It's said that the essence of all beautiful art is gratitude, and I'm here to express our gratitude towards everyone on the occasion of inaugural ceremony of Virtual Labs hands-on workshop for faculty of all engineering disciplines. This pandemic has vanished the various boundaries, and now it's time to work not only in multidisciplinary domain but also cross-institutional way, and hence the event is also a collaborative effort, a joint venture. We are fortunate to have with us the premier leadership to grace the occasion. I would like to extend our deep sense of gratitude towards today's chief guest, Dr. Nitin Karmarkar sir, Honorable Vice Chancellor, Savitribai Phule Pune University, Pune, for his inspiring address. Thank you, sir, for your exemplary efforts to empower our teachers with knowledge and skills. I would like to propose the hearty vote of thanks to guest of honor, Dr. Manohar Chaskar, Honorable Dean, Faculty of Science and Technology, SPPU, for gracing the function. Today, we got an opportunity to listen to visionary behind the virtual labs, Honorable Dr. Santosh Narona sir, Principal Investigator, Virtual Labs, IIT Bombay. I express my sincere thanks to Narona sir for sparing his precious time for us so as to lay down the foundation and to provide the context of deliberations, especially his word hub and spoke. I would like to express a deep sense of gratitude for Dr. D.S. Bomani, Honorable Chairman, Board of Studies, ENTC, SPPU, and Principal of AISSMS College of Engineering, Pune, for his motivation in including VLabs in the curriculum and hence his passion to take technology advancements to every faculty and student. I sincerely thank Honorable Director of Pune Vidyarthi College of Engineering and Technology, Pune, Professor R.G. Kaduskar sir, for his inspiring presence and a warm welcome note. Team of IITB is continuously mentoring the virtual lab development with a keen focus on the quality assurance and new initiatives. I express my sincere thanks to today's keynote speaker, Mr. Pushpadish Mishra, Project Manager, Virtual Labs, IIT Bombay, and Mr. Jay Mathur, VLab Team, IITB. I acknowledge the gracious presence of Chairman of Board of Studies of various faculties of SPPU and Board of Studies members, directors, principals, head of the departments, deans of various colleges, and senior faculty members. I appreciate the involvement of our co-host leader, Dr. D.G. Bhalke, head of ENTC Department of AISSMS College of Engineering, and VLab Nodal Coordinator, VLab Technical Coordinator, Professor Nitin Maure sir, and the entire AISSMS team, and thank them all for a successful organization for this event. Friends, PVG COET has well understood the need to change. Instead of becoming the victim of change, we started our journey for change makers with the grand and sustainable support by the management of Pune Vidyarthi Group. I take this opportunity to express our sincere thanks to Honorable Shri Sunil Redekar, Registrar of Pune Vidyarthi Group and Director of the college. The VLab Regional Center team is working day and night for exploring the VLabs to all the participants through demonstrations and hands-on. I appreciate the consistent efforts of VLab Nodal Coordinator of PVG, Professor Minal Apsangi, and the Nodal Technical Coordinator, Professor Urmila Kalshetty. I'm pleased to mark my appreciation to a team which will be demonstrating virtual labs of various disciplines in afternoon session, the one we have already session is over. Professor Ranjita Ghosh, Professor Kshama Balbude, Professor Aditya Dongre, Professor Priya Deshpande, and our students, volunteers, and coordinators. I'm happy to acknowledge the accomplishments and thank Virtual Labs regional coordinators of PVG COET. Regional Coordinator Professor Tanuja Khatakar and Regional Technical Coordinator Professor Manish Nagoshi. I appreciate their incredible job, not only in utilizing VLab, but building a team to develop new labs, reaching to community and following the path of Pune Vidyarthi Griha, that is serving the society through knowledge resource. And before I conclude, I extend a big thank you to you all and best wishes to all the 1,000 participants ready to get equipped with virtual labs and ICT tool to empower the teaching learning process. Once again, I thank you, and I know everybody is eager to go offline and have a delicious lunch. So thank you and have a nice time for the entire day. Thank you. Over to you, Bhargav sir.
Okay. Okay, thank you, madam. I request Khataukar madam for further announcement. Khataukar madam.
Minal ma'am? Yeah. Yes, sir. Minal ma'am, can you please do the honors?
Yes, ma'am. Thank you so much. So we will have our hands-on session continued after the lunch. We will meet, all of us, we will be meeting here again sharp 2 o'clock. Sharp 2 o'clock, we will be starting our session on hands-on. And the way we have shown the hands-on session for the physics lab, we will be covering all the other labs also. As Khataukar madam has mentioned, that we will be giving you some deliverables later on during the sessions also. And one of the most important deliverables will be your subject mapping for each faculty. That means for each department, which subject is mapped to which particular virtual lab. Team PVG COET has taken a great efforts to do all these things. So those are the takeaways, one of the important takeaways for this event be getting in the second session. Thank you all.
Yes, thank you, ma'am. Thank you, ma'am. While joining for the second session, it would be better if we could join from using your laptop, because following the demonstrations, you'll have to start with the hands-on session. So preferably you should have a laptop then, or a desktop, you can say, so that you can work comfortably. If it's not available, you can directly use your mobile phones in that case. I think with this, we can end the session. Balke sir, we can break for lunch.
Yes, madam.
Yeah, thank you so much. Thank you,
Always
everybody.
at 2 o'clock. Attendance
Yes.
link is floated on the chat box. So I request all participants to mark your attendance of the first session. Yeah, and this Zoom session will open for 5 more minutes. So till that time, please you mark your attendance and you join at 2 o'clock. Is it okay, madam?
Yes, sir. That's right.
Yeah. Okay. Okay, madam. Thank you all.
Thank you, sir. Thank you, ma'am.
Thank you. Yeah, thank you so much.
Hello, Minal ma'am. Hello, Minal madam. Hello, madam. हाँ मैडम
Hello, Nitin sir. Hello, Nitin sir.
Hello.
Can you make please Manish sir as a co-host?
I have already done.
Okay, okay. Thank you, sir.
Minal madam, just check if I am audible or not.
Yes, madam, you are audible, loud and clear.
Okay, fine. Thank you.
Minal madam?
Yes, sir. Am I audible?
Yeah, madam, you are clearly audible. Now we can start the session.
Okay. Yes, sir. Definitely.
Yes, madam.
Good afternoon, all,
Please,
and
yes.
welcome back to our second session. Welcome back to our second session for our virtual labs hands-on workshop. As we saw in the morning session, one physics lab. Right now, we'll start with a lab which will be demonstrated by Professor Priya Deshpande, who is assistant professor in ENTC department in PVG's College of Engineering and Technology. She's having 13 plus years of experience, and she will be demonstrating us the lab, which is mapped to disciplines like electronics and telecommunication, instrumentation, and electrical engineering. Over to you, Priya ma'am.
Yes, thank you, Minal ma'am. Am I audible clearly?
Yeah, madam,
Yes.
you are audible.
Okay, thank you, sir. Good afternoon, everyone. So I will be demonstrating you the sensor modeling and simulation lab developed by College of Engineering and Pune. So I will start my screen sharing. So is my screen visible, sir?
Yeah, madam, it is visible.
Okay, fine. So before going to the lab, let me tell you that this sensor modeling and simulation lab is mapped to the SPPU syllabus for second year instrumentation and control branch. And for that subject is sensors and transducers. Now to enter into the lab, we have to first go to the IITB VLabs site by typing vlabs.iitb.ac.in, where you can see there are so many disciplines. Out of that, you select electrical engineering, and in electrical engineering domain, again you can see there are many labs, and you can select the sensor modeling and simulation lab. So now this lab page is open. So on the left hand side, you see the discipline electrical engineering, and below that you see two links. One is introduction and the second is a list of experiments. So if you click on the introduction link, then it will give you a brief introduction about the lab of what exactly this lab contains. So in this lab, we will learn various sensors and their operations, and we will characterize the temperature sensor, LVDT, strain gauge, etc. Below that, you have list of experiments tab. So I will click on the list of experiment tab. So it displays the list of experiments. So this lab contains total 8 number of experiments, which are for 8 different sensors. So I will be demonstrating characterize the temperature sensor RTD experiment to all of you. So click on the characterize the temperature sensor RTD. So it will open the page where you can see this particular experiment, characterize the temperature sensor RTD. On the left hand side, you can see the links which are aim, pre-test, theory, simulator, procedure, audio, video, post-test, review questions, reference, photo gallery, and feedback. So if you click on aim, it gives you the aim and objective for this experiment. So aim is to understand the working principle of RTD, and objective studying of static and dynamic characteristics of RTD and effect of various parameters on RTD performance. Then you can go to pre-test tab. So where you can see a set of 5 questions. So you can say this is a prerequisite understanding required by the students for the study of sensors and the transducers. So I randomly click on the answers here. And then I say submit. So once I say submit, it will give you the instant test results, the number of questions you got right, you didn't get right, and grade in percentage. So you can take this quiz again by clicking on take the quiz again option. Also, you can view the solution for getting the solution for this particular quiz. So this is for checking the understanding of the students. So again, I go back. Then you have a basic theory of this experiment. I click on the theory tab. So here you get all the detailed theory about the temperature sensor RTD, starting from the prerequisite, basic definitions of temperature, electrical resistance, then how temperature can be measured using RTD, then RTD structure and the materials used for the RTD, how the temperature RT is calculated using the formula, some of the graphs, and then you have some calculations and the specifications for the RTD. So this tab covers the detailed theory needed to perform this experiment. Next tab is simulator, but before going to simulator, you can go through the procedure tab and audio video tab so as to follow the procedure to be followed while using the simulator. So first I will click on the procedure tab. I'm getting some issue here.
Nagosha sir,
Okay.
is it fine? Priya ma'am, is it fine?
Yes, it has opened now, ma'am. Thank you.
Okay, fine, good.
Yes, okay.
Continue, ma'am.
So if you click on the procedure tab, you will find detailed stepwise procedure for performing both the experiments for static characteristics of RTD and for second experiments dynamic characteristics of RTD. So you can read these steps and accordingly you follow these steps so as to perform this experiment on simulator. If you click on the audio video tab, so it is taking time to open the page.
Priya ma'am, you can switch off your video and you can get you can save the bandwidth.
Okay, ma'am. Yeah, fine. Okay, so in this audio visual tab, you can see a visual demonstration of the simulator by the faculty. So once you finish with the procedure and audio visual demonstration, you can now switch to the simulator tab to perform the experiment. Okay, so here you get this option, click here for simulator. So click on that. Okay, now this GUI for performing level 1 static characteristics will be open. Now on the left hand side, you can see the setup, and on the right hand side, you can see the control panel where you can adjust the parameters for the RTD. So first parameter is the material. So in the drop down list, you can select the material used for RTD, that are platinum, copper, nickel, and balco. So for experimentation, I'm selecting platinum. So as soon as you select the material, it will display the temperature coefficient value alpha for that material, and also it will display the temperature range for it. Then there is one parameter called as R0, which is the reference resistance at the reference temperature. So again, in drop down box, you have different values of resistor. So I will select 100 ohm for reference resistance value, which is a resistance at a reference temperature of 0 degree. So then you have this get temperature tab where it will give you the random temperature for which the resistance of RTD is to be evaluated. So I click on this get temperature tab, and now I got this value 17 degrees centigrade. So I need to find the resistance of RT at temperature 17 degree centigrade. So for this, you can refer to the formula tab where it will give you the formula for calculation of the resistance RT. Now I will calculate it using the formula. So it is 17 degree. So 17 multiplied by 0.00385, that is the temperature coefficient, plus 1 is equal to into 100, that is equal to 106.545. So I have to round it up to 2 digits. So I will round it 106.55 and enter here. So 106.55, and then I say submit. So if my calculation is correct, it will give you the correct option here. So for plotting the graph of the static characteristics, I require minimum 3 number of calculation for 3 different values of temperatures. So if this value is correct, then again I repeat the procedure and I go to the get temperature tab. Now I got 473 as my temperature value. So again I go for calculation. I will do 473 multiplied by 0.00385 equal to plus 1 equal to into 100. So I'm getting 282.105. So I will enter it here, 282.11, and say submit. So that value is also correct. And now I will calculate the third value. So that gave me minus 105 degree centigrade. So again, I will calculate for that minus 105 into 0.00385 equal to plus 1 equal to multiplied by 100. That gives me 59.575. So I will enter 59.58 and say submit. So now I have calculated the RT value for 3 different values of the temperature. Now here in the drop down box, in the comment box below, you can see all the summary of our calculation. Now after getting 3 different values, now you can see that this plot button is now enabled. So you can click on this plot option so that it will plot the graph of temperature and resistance. So here is the graph. So you can see these are the points for which we have calculated our resistance value. So that's about the static characteristics. One of the beauty of this static characteristic is that this get temperature tab gives you the random values of the temperatures. So if you are giving it for the students, then every student will be getting a new value of a temperature, and the graph of every student that will be different because the calculations will be different. So once you finish the level 1 with the static characteristic, the tab for level 2 dynamic characteristics will be now enabled. So I will click on the level 2. One more thing, that you can try the static characteristics by selecting different materials for RTD as well. I will click now the level 2 for getting the second experiment dynamic characteristics. Okay, so this is the GUI for study of the dynamic characteristic. So on the right hand side, you can see there are so many options: bare, with sheet, thermowell, like that. So basically the dynamic characteristics, it plots the dynamic response of RTD. That is how fast your RTD responses to the step input change, that is plotted in this dynamic characteristics. To start with, I need to select this bare option. Ma'am, somebody can minimize that see waiting room option, because that tab is not visible to me, the time constant.
Okay. Maure sir. Maure sir. Maure sir, are you there? Okay, madam, I will ask.
Okay.
Hello, Priya ma'am, just
Are
click
you
on
able to
that.
see now?
Okay. Okay, fine. I will dictate. No issues. Okay. So as soon as you select this bare material, the material is by default platinum. This particular tab displays the time constant value. Now I know this time constant value, it is 1.17 seconds for bare minimum material. Then if I click on with sheet material, I need to click on the OK option first. Sir, I'm not able to click on the OK option because that's still I'm getting waiting room message over there.
Madam,
No.
you just click on that waiting room message. It will just pop up and it will go.
Yeah, I will minimize it. Okay, thank you, ma'am. Okay, so it displays the time constant of 1.17 seconds. So I click on OK. And on the left hand side, you see that the construction of bare minimum RTD is displayed. So I will go to the formula tab later. Then you can select option wet sheath. Okay, so if you want to add some extra mechanical strength to RTD, you can cover it with sheath. And for that, again, you have the option to select for the sheath material as well as the thickness. So for experiment, I select the material as SS304 and thickness I select as a 0.5 mm. So as soon as I select this 0.5 mm, again the window is pop up that will display the time constant of RTD with sheet. So, okay. And again on the left hand side, you can see the construction of RTD changed. Now it's with bare minimum and with sheet. Then I click on this thermo well. So that will add an additional thermal layer to the construction. And again, I have the options for selecting the material. So for this experimentation, I select SS304. Thickness, I select 1 mm. Filling material, I select MgO powder. And as soon as I select the material, it is again displaying me the time constant for the material with thermowell added. So you can note down this time constant values for bare minimum material, for wet sheet and for thermowell, and you can verify all these three time constant values by looking into the formula tab. So this is a formula tab where you can see the calculations to be done for a bare minimum material time constant. Then this is the time constant with sheet and this is the time constant with thermowell. So all the parameter values are listed in table. So accordingly, you have to calculate and verify the time constant value. So once you select all these construction types, then you can plot the performance or the dynamic characteristics of RTD with all these combinations. So I will say plot now. So just when the graph is inverted, I will switch plot again. Okay, fine. So it is showing the graph of temperature versus time. So this is yellow one is the step input and the remaining ones are the responses of the RTDs to the step input. So this blue one is for bare and this red one is for thermowell. So as you see that for bare minimum material, the response time is less. So it is fast as compared to the response time with respect to the thermowell. So here what you can ask students that to try different materials with different combinations with their different thickness and compare the performance of each combination of the RTD. So this level 2, it completes the dynamic characteristics of the RTD. And now I can go for the main tab of this experiment, and then I can go for post-test option. Okay, fine. So again, this post-test option has 5 questions. So basically this post-test is used to check the understanding of the students about this particular experiment. So you, as Ranjita Ghosh ma'am said, at your side, you can also prepare a Google form which will have a questions based on this particular experiment, and you can ask them to submit the Google form, and then you can analyze it later. So that is posted. Then you have a review questions tab.
Yeah, Priya ma'am.
Yeah, yes, sir, I'm there. So it is getting time to open up. So this is a review question tab where you can see a few questions related to this experiment. So these questions you can ask students for the assignment, and that assignments you can get it submitted through Google Classroom method. Reference tab. Okay, this particular experiment study. So it has a books references and some web references for getting some additional information about the related topic. Photo gallery.
Priya ma'am, are you there?
Yes, ma'am. Yes, I'm there. So my page is getting time to reload. I'm there. I checked the internet speed at my side. It's okay actually. So on this photo gallery tab, you can see various RTD structures. So you can ask students to do the literature survey of various structures of the RTD and different types of RTD probes, and then you can have a RTD transmitter manufacturing to load. But you can go through this photo gallery later while you are in a demo session. And then the last tab is the feedback tab. So about feedback tab, Meenal Apsangi ma'am will elaborate about it later. So I hope you understood the demonstration of this lab, and I thank you all for patiently listening to my presentation. Thank you so much. Over to Meenal ma'am. Yes, now the images are coming. So the steps you can see here, RTD transmitter manufacturing steps. So everything is given in detail so that you can show it to your students and ask to do this literature survey of these sensors as well. So thank you so much. Over to Meenal ma'am.
Thank you, Priya ma'am. We'll start with now the next session by Professor. Just a minute, I'll just share the screen. Now we'll start with the session for Computer Engineering and Information Technology stream. We have with us Professor Aditya Kumar Dongre. He's working in PVG's College of Engineering from last 13 years. He is virtual lab coordinator for the Department of Computer Engineering. He'll be demonstrating today the lab on the computer graphics. Over to you, Dongre sir.
Thank you, ma'am. Am I audible, ma'am?
Yeah, sir.
Yes,
You are
sir.
audible.
Yes, sir.
Okay. Thank you. So today I'll tell you how to access the VLab. It's a VLab on the computer graphics is based on the computer graphics VLab. So in the LPU curriculum, the basic assignments are there on this lab. So first we'll see how to access the lab. So as already it's explained in the previous that we are going the URL that is vlabs.iitb.ac.in. Click on that. Then we can see the
Dongre sir, kindly switch off your video and then you can start sharing your screen.
Yeah,
Thank you.
So click the VLab tab.
Sir, please share your screen.
Just 1 minute. See now?
It's not yet visible, but I think it's now. We'll just wait for a minute. Yes, now it is visible.
Okay. So we use the mobile internet to so just you need to type vlabs.itb.in in your 1 minute.
Dongre sir, your voice is not clear.
Okay. Now
your voice is breaking, sir.
I'll change the internet connection.
I think Dongre sir is facing some connectivity or the network issues. We'll just wait for a minute. Dongre sir, are you there? Dongre sir, we can't hear you. You're not audible. Dongre sir.
I'll just call and check what is the issue. Just a minute.
Yes, ma'am.
Yes, sir. Your screen is visible. You can continue, sir.
Now it's audible, right?
Yes, you're audible now, and your screen is also visible. Please continue, sir.
Sorry for the interruption.
And I request all the participants to kindly bear with the network issues. Yeah, thank you.
Right. So first we have to use the vlabs.iitb.ac.in link. Enter it. So you'll get the home page of IIT Bombay Virtual Lab. Here you'll get a VLabs Dev tab. Click on that. So you'll get again here options like there you have to go to the Explore Lab. So just click on the Approved Labs. Under the Approved Labs, you go to the under Computer Science and Engineering, there is a Computer Graphics Lab. Click on that. Then you will get here at the left hand side, there is an introduction, list of experiment, target audience, and course alignment. These links are there. So here introduction is about the course, virtual lab, computer graphics virtual lab. So it's a message over there. So go and see the list of experiments. So here we have 8 experiments here. So the first experiments we are going to see here, that is digital differential analyzer, line drawing algorithm. So we click on that. And here on the top, you can see you'll get few tabs here like aim, theory, pretest, procedure, simulation, post-test, and references. So we are going to use these tabs, and these tabs are same for all assignments. So what is our main aim? To learn DDA, line drawing algorithm. So we'll go to the next tab. So you can get the theory about DDA algorithm. So it's about scanning, and so how scanning takes place and how the pixels are plotted. So this theory about that. The next one is we go to the pretest. So pretest is basically to test the knowledge of the students. So once they go through the theory using the book or using this theory given in the virtual lab, so just they have to select random. Let's say we select few options here. So there might be few correct and few wrong. So just you have to submit the quiz. So you can see here at the end, bottom side, there are 3 out of 5 is coming because there are the 2 questions which are wrong, right? So we need to check here. So here we have only 2 options. Just I change the options and again I submit the quiz. So out of 5 out of 5 is there. So like this, you can check the knowledge of the students. So next is a procedure. So here, what are the types of the lines? So generally we can have the vertical line, we can have the horizontal line, gentle slope, sharp slope. These are the different types of lines are there in the computer graphics. So we have pre-stressed questions based on those. Now the next tab we'll see, there is a procedure. In the procedure, there is a algorithm for the DDA is given. So steps are there. So students can refer these steps. This is mentioned in the very simple language. So just they can take the notebook and they can start taking the coordinate and they can calculate the x and y as per the algorithms. 7 steps are there. Now we move to the simulation tab. In the simulation tab, there are, if you see, there is a Q1, Q2, Q3, Q4, and Q5 are there. So these are the different coordinates are taken as an example. So there is a vertical line is also there. So different examples we have taken. So what you can do, if you need to select one of them. So first I'm going with the Q1. So the coordinates are 2, 3, and 12, 8. So these are the x1, y1 and x2, y2 respectively. So just what you have to do, you have to start with the 2.3. So just I'm selecting right now. So here, I suppose using algorithm, I got these 2.4 and 3.4 as a next pixel. So I'm clicking on that. So if you in between, if you want to refer your procedure or algorithm, so there is a link is also given on the top. So just you need to click here, pop-up procedure. So here you can refer the steps and you can calculate the x and y coordinates. Just 1 minute, sorry. Once again, I go to the computer graphics lab, directory list of experiments. I click on the DDA and we go to the simulation part. Okay, so just when I start, so we were here. So on 2, 3, next suppose we calculated 2, 4. So 4, 5, something like this. Just I'm randomly clicking on this. So 10, 11, and there's a 12, 8. So let's say I got these pixels. So I click on the pixels and then I click on the check coordinates. So it will show you whatever the pixels you have clicked or plotted, it is a right or wrong. So you can see here at the right hand side, there are the correct coordinates are given. So calculated by using the algorithm, DD algorithm. So here these are the x and y values are there for the next pixel. So here green is shows you the correct one. Red is for the wrong. You have plotted a wrong pixel. And black is the basically which are not plotted. So again, we'll see with the same example with the correct pixel values. We need to clear the canvas before that. So when we are using the other example for plotting, so we need to clear the canvas, then we can go with the options like I clicked on the Q1. So 2, 3, 12, 8, these are the coordinates. So again, I start with the 2, 3. The next coordinate is the 3, 4, 4, 4, then 5, 5, 6, 5, 7, 6, 8, 6, 9, 7, 10, 7, 11, 8, 12, 8. So this we reach to the 12, 8, y2. Now we can check the coordinates. So you see here, all the coordinates, all the pixels basically are green. It means whatever I calculated using the algorithm is correct. So for the students, you can give the different options and you can ask them to calculate and you can cross check it. But here in this simulation, there are the fixed coordinates, 5 coordinates are given. So later on, you can modify, you can give your own example to the different students. So they not ask to other students, so they have to work on that. There is another tab is called as post tab. Here, there are the different coordinates are given, and there are a few options are there. So when during the rasterization process, what will be the answer? Here, so here, let's just click. So I'm clicking on the correct answers here. Similarly, as we use the pretest, post-test also the same way. It shows you the at the end the score of the student. So I click on the third option, fourth and fifth. So here got 5 out of 5. And there is a last tab is references. So here references are there. So you can use these books for further references, the theory around the algorithms or about the basics. If you are interested in the more theory, then you can go with these books and you can refer. And I forgot to mention one thing, that one of my colleague, Professor Anil Badgale sir, has developed this lab. So this lab belongs to the PVG COT Computer Engineering Department. And one of the student was involved here, that Mr. Parth Parikh is a BCom student who has helped to develop this lab. Thank you. Thank you very much. Apsangi ma'am. Apsangi ma'am. Can you hear me?
I think Apsangi ma'am is disconnected.
Okay.
Yeah, just wait.
Apsangi ma'am is asking to unmute her. She is in the meeting.
Just wait.
Maure sir, please make her co-host, I think. She was out of meeting. Okay.
Madam, you can unmute yourself.
Yes, sir. Am I audible? Sorry for that. Due to those connectivity issue, I got disconnected.
Okay. Yeah.
You're audible.
Yes. Thank you so much, Dongre sir. And I'm really proud to share that whatever the lab Dongre sir just demonstrated, this is the lab which is developed at PVG COET by Professor Anil Badgale sir and one of our student, Parth Parikh. So that is really a great job by both of them. So let's start with the next session. And next session, I want to invite Professor Urmila Shetty. She is also a Nodal Center Technical Coordinator of VLabs PVG COET. She's having 15 plus years of experience, and now she is demonstrating a lab which will be helpful or which is mapping to all the disciplines. Over to you, Urmila ma'am.
Thank you, Meenal ma'am. Good afternoon to one and all here. I'm going to demonstrate you the lab which is called as Virtual English Communication Lab. For that, I'll share my screen. yes, to visit this lab, you have to first go to the website vlabs.iitb.ac.in. Therein, among these disciplines, you need to select the discipline physical sciences. Under physical sciences, this lab is listed out, virtual English and communication lab. So you have to click this lab. You will be able to open this particular page. This is a very wonderful lab developed by IIT Guwahati, and it is very useful for almost all disciplines. Or maybe it is or in employability skills development lab, maybe with any name, or maybe for MBA discipline, it is like a business communication. So you may use this lab in some or the other way for your student. So when you come to this page, you will see the list of experiments that are available, that you can see here: business communication, common errors in English, communication skills, grammar, and there are many other topics are given over here. Let's see one topic so that you will get an idea about it. Let's go to business communication, because business communication is the most common topic that we have, maybe with few syllabi I have seen. So in all of those, it was there. So I find it to take this. Here, there are different options than the tabs we have seen previously. So we have very few tabs, but the topics in one particular experiment are quite a good number of topics we have, and we can conduct many activities under for these topics. So you can see the part, what topics can be considered under business communication have been listed out here. The procedure page is not available right now, so maybe it is a problem at their website. So you'll not be may not be able to see this procedure link right now. But if you click on self evaluation, yes, as you can see under business communication, we can have these different topics: spelling check, matching synonyms, matching negotiation strategies, and there are various other. For each one of this topic, the subject expert can better tell about this. That each one of these topics you can have a separate session and you can conduct the activities. So let's take matching negotiation strategies here. Click on exercise. So there are different business situations are given, and how to handle those situations. So one column is what should be done.
Urmila ma'am, just a minute. Urmila ma'am, sorry to interrupt, but your voice is breaking, Urmila ma'am.
Okay, to network connection. Should I repeat it?
Yes, just from those two columns, it shows the two columns.
Is my screen visible?
Yes, your screen is visible. Just the audio is breaking in between.
Okay, I'll repeat. I'll go back.
No need to go back. You can start it from here itself.
Okay, fine.
Yes.
So
just explain what are those two columns.
Yes. So in this particular experiment, there are two columns given. One column represents the action or a strategy, and the other column has been for business situations. So what students need to do is match the strategy with the business situation. These ways to handle situation. So how to handle those situations that has been taught with this particular experiment. So just randomly will do it. Something like this. You have to drag the situations in front of the correct strategy like this. So once you are done, you have to click on check, will show correct matches. So you go and do this, you get correct matches, so that students will be able to understand the correct strategy for certain business situations. So few of the strategies are given in the experiment. Let's go back. Okay, so like this, these exercises you can conduct for the students. Students can their own, they can complete these exercises, and they can share the snapshots to what level they have performed these exercises. So let's see one more, which is also a very good experiment in this particular lab. This one, listening skills. So if you click on this listening skills, theory part is given, then we'll see the self-evaluation part of this. Here, different passages are given, and these different passages are audio passages, audio clips are there. So when you click on listen, you will be able to play the audio clip. I'm not sure if you'll be able to listen it, but you can try it on your own. So okay, I don't think it is possible here to show get it played. Fine. So passage 1. So you click on listen so that that audio clip will be played. Now, based on this audio, there are some questions that will be asked. So you need to answer those questions. So with this, the listening skills can be improved for the students. So if you go through the list of the experiments in this particular lab, you will understand that there are, for each of the topics, you can frame your own active learning strategies. Active learning strategies, different ways can be we can frame those active learning strategies, and we can evaluate the students also by sharing their scores with the help of screenshots, or maybe we can frame some different kind of activity with the help of all of these experiments that are available on this particular website or on this in this particular lab. So in our college also, we used to take it for all disciplines. For the second year, we have communication lab, soft skills lab. So since 5 to 6 years, we are taking the help of this particular lab for our courses in our college. So that's all from my side. Over to you, Minal ma'am.
Thank you for that wonderful explanation, Urmila madam. We'll go for the next speaker. Okay, so our next speaker is Professor Kshama Balgude. She's a virtual lab coordinator for VLabs for the Department of Information Technology. She's working in PVGs from last 10 plus years. And she'll be today demonstrating you a lab on data structures, which we know that from a computer and IT background people, and now even for the ENTC also, we have this lab, data structure. So over to you, Kshama madam.
Thank you, Minal madam. Am I audible, Minal madam?
Yes, madam, you are audible.
Okay. Good afternoon to all. I am Kshama Balgude, going to demonstrate data structure lab. Is my screen visible, Minal ma'am?
It's just sharing. We'll just wait for a minute. I'll tell you.
Okay. Today I'm going to demonstrate data structure lab. This lab is mapped with the data structure subject in ACIT.
Yes, your screen is visible now.
Okay, thank you, ma'am. So for a data structure lab, we need to first go to the site vlabs.iitb.ac.in, and when you go to the site, you can see here different type of tab available. You have to click on a tab lab. after that, you can see different many disciplines and domains here. So for data structure lab, you need to click on a computer science and engineering discipline. And so here you can see many VLabs are there, which come under the computer science and engineering. And from these labs, I'm going to select data structure. So click on a data structure. So in the leftmost corner, you can see the information regarding this lab is given: introduction, list of experiments, target audience, course aligned, prerequisite, and feedback. Okay, so the information regarding the VLab is given. So we directly start with the demonstration. So click on the list of experiments. Here you can see total 9 experiments related to the data structure subjects are given. From these experiments, today I am going to demonstrate graph traversal. So click here, graph traversal. So this is the experiment. This is the window for the experiment graph traversal, and you can see again on the left hand side many tabs are there: introduction, theory, objective, simulation, quizzes, and feedback. So I request you all the participants, please tell your students to go through all these tabs, especially for the theory tab. So here all the theory regarding the graph analysis is given. The algorithms for DSF and DSS are given. So through that they get more knowledge regarding this particular topic. For simulation, we directly click on the simulation part. So for this particular lab demonstration, you require some prerequisite. You need to install a flash player and all this things. So what are the prerequisites required for this simulations are given here. So you can click here, and as well as the links is also given here from where you can install that software. Okay. So for demonstration simulation, we need to click on graph DFS. So you can see this is the window. Okay. The first, you know it very well what exactly the graph traverses. Here you have to draw the graph first, and you have to travel.
Sorry to disturb you, Kshama ma'am. Your graph screen is not visible. We are still stuck at that graph DFS BFS.
Might be because of some problem. Is it visible now? Madam, is it visible now? Meenal ma'am?
Not yet.
No, not yet.
There could be some network issue at your end. Just check.
Ma'am, can you stop sharing and share it again?
Yeah, that will also do. Yes.
Okay, sir. Thank you.
Hello, Kshama ma'am, share the whole screen.
Yes, now, sir? Now is it visible?
Yes, now it is visible.
Okay, thank you, ma'am. So now you know that what exactly BFS, here you have to first draw the graph. So first is drawing a graph. How to draw the graph? So for that, you have to first click on draw graph. Okay. So you can see there is the blank screen, and two important parts with the graph, that are the vertex and the edges. So when we click somewhere in the screen, I have clicked here, so you can see there is a red circle with some number. Okay, so this is nothing but your vertex. Similarly, you can draw the other vertex. Okay, now how to draw the edge? So for that, just start the dragging from starting vertex and drop here at the end vertex. So you can find there is one line between these two vertices, and again you can, this is edge actually, the green line is nothing but the edge actually, and you can see here the small circle near the edge, near the vertex 1. It means this is a directed graph, your arrow is toward the vertex 1. Okay, so suppose if you want to change the graph, so you can press the Z here. So you can see here the edge is removed. Again, when I press the Z, you can see the node number 1 is also removed from the screen. So in this way, you can draw the graph. So first, draw the graph here. So all these are vertices. You have to just click on the screen and then join all the vertices using edges. Okay. So here you can draw the directed graph. So now I have finished drawing part, and I do not want to modify this particular graph. This is a final graph for the process. So just you have to press escape. So when you press escape, you can see here different tabs on the window. So you can select any algorithm. You can select DFS or DFS, which traveling you want to do. So I go for DFS, depth first search. So click here. So you can see there is a message, click on a source node. So this source, you have to select the node from which you are going to start the traversing. So I have select here 0. Okay. Simultaneously, you can see here at the right to leftmost corner of this particular window, some numbers are given 0, 1, 2, 3, 4, 5. These are the nodes of your graph, and something is given below that. The D represent the order of the visit that particular node, and F represent the backtrack. Okay, backtracking. Okay, order of the backtracking, and D represent the order in which vertices are visited. Now you can see there is one more button, solve. So this particular problem you can solve by two ways. Means the student can solve by themselves, or there is a solve button. When you click on the solve button, the simulator start the simulation. Okay, so first I go for the simulation. So I click on the start button. So you can see simulator start the problem solving, and simultaneously the values of D and F are going to change it here. Okay. So the when your node is in the red color, it means it is not visited. When it is in green color, it is visited. And when the node is in a gray color, it means it is partially visited. Okay. So whole graph is visited here. Means this is in the final output. Okay. Then I want to solve by myself. So for that purpose, just click on a screen. So again, you will get all the menus. Okay. So you can draw another graph by clicking here screen. But I want to use the same graph here. So that's why I click on the reset graph. Okay, so what is the initial? We will get the initial graph. Means all the nodes are in the red color, so no visited. Okay, so again I'm going to select the same algorithm DFS, and now I want to solve this problem. So again you need to select source node. Again I'm going to select 0. You can see here again the same button is there, solve, but I want to solve this particular problem. So start the traversing. So as per algorithm, I first go to the, and simultaneously you can see here below the node 0, this is the node number 0, you can see 1. It means I visited the node 0 first. Okay, and then I'm go for the next node 1. Okay, Okay, so I'm visited node number 2, the second click or in the second time. When you click on any node, it means you visit that particular node. So I'm second time and click on 1, so I'm visited it. Okay, second time I visited the node number 1. Now I'm click on to the 2. Okay, so you can see here this is wrong. Okay, I cannot, as per the algorithm, I have to go for 3, but I click on the 2. So at the same time, you can see there is an this message. This node is not a neighbor of the current node, and you will give the hint about it. Okay, so select the other one. Now 3, now 5. Okay, so you can see the order. First I visited 1, so it is 1. Then I visited 2, so it is 2. Third time I visited my third click on 3, so it is 3. My fourth click on the 4, so the 4. So this is the order of the order in which you are going to visit that vertex. Then there is no nodes from the 5. So I have to go back, and when I click and when I go back from 5 to 3, so you need to click on 3. So you can see here the color of the 5 is changed, means you are visited the node number 5. Okay, and simultaneously you can see here in the F tab the value of 5 below 4. This when I visit that particular order, when I visit that particular node, and the 5, it means on that click it backtrack from 5 to 3. On the 5th click there is the backtracking from which node it is the backtracking is happened from node number 5. So it will go here again, go back. Okay, then select, then suppose I have select 0, so again it gives me the wrong answer. Okay, so you need to click on 4, then go back. Okay, then go back. Okay, then go to the 2, and then again go back. So you can see here all the nodes are in a green in color, means I have visited all the nodes from the graph. Okay. So similarly, you can do it for the breadth-first search also. So you can use the same graph, or you can here just select it and stop. So this is a demonstration. You know that there is the level-wise traversing. So these are the levels. Okay. So this is about the BFS and DFS graph. Similarly, there are many experiments are given. Okay. So you can go through all these experiments. And for assessment purpose, what you can do, you can give the different graph to the different batches, and you can tell the student to send the videos of that particular simulation or the snapshot of that simulation. Okay, so it's through this process you just come to know whether that student is perform that experiment or not. Okay, and all these, just please go through all these experiments. If you have a query, so you can write it in a Google form. So thank you all for listening me.
Thank you, Shama ma'am.
Over to Minal ma'am. Thank you
Yes,
all.
thank you so much, Shama ma'am. Now, next speaker is myself only. So I'm Professor Mrs. Meenal Apsangi. I'm working as a nodal coordinator for VLabs PVG COIT from past 3 years. Before that, I was a department coordinator. Actually, I'm from information technology, or you can say computer background. But one stream which remains aside till the point. So I'm just going to quickly cover that. But of course, as I'm not the subject expert of that, I'll just show you how you can go about those labs. So I'll just start sharing my screen.
Shama ma'am, can you unshare your screen, please?
Nagoshe sir, is my screen is visible?
Yeah.
Yes. So we are coming back to the same site again and again, that is VLabs.in. Okay. So there are a lot of labs and disciplines available, as many speakers since morning they're saying. So you can see that there are electronics, computer, electrical engineering, mechanical engineering, chemical engineering, physical sciences, and chemical sciences. So I'm just going to touch a few things with respect to chemical sciences. And whatever are the settings I'm telling right now with respect to chemical science lab, those are applicable for each and every lab available under VLab, wherever there is a requirement for such a kind of a settings. So we'll just go to chemical sciences lab. So in the chemical sciences lab, lots of labs are available. Out of that, there are few labs which are directly mapped to the first year engineering chemistry syllabus. So let's say we'll go for physical chemistry lab, or okay, we'll go for in physical chemistry lab. Okay, so this is one of the experiment which is also mapped. So under physical chemistry lab, you have these many labs available. So you can just click on, as all other faculty members, they have told you that for every lab, how is the structure. Now from all these demonstrations, you might have got that this VLab platform is a complete package. You get theory, you get almost every kind of a lab manual over here, which we can use it in this pandemic situation. So let's say I'm just going for spectrophotometry. As I said, again, I'm not from the chemistry field, so I'll just show you some of the things why I have chosen this particular lab is there are few settings which are applicable to every single lab where flash player is required. So as you know now that these are the common tabs for every single lab available in under VLab platform. So there is a theory, there is a procedure. So this entire procedure, you can follow it and you can get how a simulator works. Then there is a self-evaluation tab available. Okay, now here is some of the things. For some of the labs, you will get this screen, which is sign in to view the content. Now you can either free sign up or you can go for login. I'm just going for login. Now these are the options available. If you don't want to go through these options like a Google or a Yahoo or all these, what you can do is you can enter your you can enter your username, password, and create an account over here at this site. But I'm preferring here by using a Google, as I've already signed in, so logged in. Because of that, it won't ask me for the password or anything, and straight away it will come for this. So if you are not logged in to your Google account, it will ask you for entering the mail address and the password. So it will come over here. Now, these are the evaluation, as all my colleagues, they have explained you, these are the evaluation. Even down, they are showing which are the other labs which are there on the virtual lab, or what are the other platforms available for the chemistry labs for this. Now we'll go to simulator. Now, once you go for the simulator, many people are going to face something like this. Fail to detect flash player, or click here to enable a flash player. So there are two things for doing this setting. What you can do is you can click over here, go to the site settings. In the site settings, search for flash. Search for flash. Flash is here in site settings. Go down. Go to the flash. Now, in many cases, it will be switched off. Now, in my case, I have already switched on. That's why it is showing here. Otherwise, it will be like this. So you're blocking the site from running the flash. So you just turn it on. Close this setting. And go over here, again, click on I. See here, it is showing flash now. You can just click on here and say allow. And close this. It will ask you, as you can see over here, it will ask you to reload your page. just reload your page. Okay. Now this setting, please remember, wherever you require a flash player setting in any of the virtual lab, you can use this flash player setting. Now it will take some time, just a few minutes. It will load that entire thing, simulator. Yes. So as I said, I'm not the subject expert from this, so you can have this experiment. There are now self-explanatory options are here. You can have a click to open. You have to place your concentration and click whichever you want, and then you have to keep it over here. And likewise, you have to perform your experiment. You get all the calculations. You have to find out what are the solutions and all those settings. I think those, as being the subject expert, all those chemistry people will be able to do it. Now, the same thing, there are assignments, there are references, self-evaluation, that is a kind of a pre-test, whether the student has understood a particular concept or not, or specifically related to this. So we can first find out whether a student has got some kind of a concept or not. If not, we can ask the student, go back, okay, you read again the theory, solve this evaluation test, and then only you perform the simulator. So this way you can perform all those experiments available under chemistry lab. There are other chemistry experiments which are available, which are under inorganic chemistry. There are many experiments are there which are straight away mapping to our SPPU chemistry syllabus. So that's all from my side. So thank you so much, and thank you for patiently listening to me. So after this, I'll directly call upon Nagoshi sir. Nagoshi sir is, now what should I say about him? Nagoshi sir is having 22 years of experience, more than that. And he is the key person, or he's playing, I can say he is playing key role to promote all the development activities and to all the virtual lab activities, initially in the PVG and now across Pune, Maharashtra region, Pune and this Pune, Satara, Sangli, Kolhapur region. He's a regional technical coordinator. So initially he was just the nodal coordinator, but because of the performance and all, now he is designated as a regional technical coordinator. He is also mentoring for developing the labs for variety of the on the national level. So before just handing over the mic to him, I'll just show you his profile. Okay. And today he's going to demonstrate labs which are directly mapping, or those are the labs which are from the disciplines like mechanical, electronics, electrical, production, chemical, mathematics, and civil. So over to you, Nagoshi sir, please.
Yeah, thank you, ma'am. Is I'm audible?
Yes, sir, you're audible.
Yeah, so I'm going to share my screen. So
Nagoshi sir, are you there?
Yeah. Just a moment. I'm trying to share.
Okay.
So actually it is giving me option to select only tabs, not desktop. Okay, no issue. Fine. So just let me know whether my screen is visible or not.
Yes, sir, your screen is visible.
Yeah. So thank you. So again, I'll go back to vlabs.iitb.ac.in. This is what is the common URL which we are using for the demonstration throughout the session. So a few things I would like to tell you about this portal. So there are labs below according to discipline and domain: electronics, computer, electrical, mechanical, chemical, and biotechnology, okay, physical sciences and chemical sciences. So this is the one area where all the PICs are contributing, and those labs are available at these locations. Your lab may be at some different location. So if you are interested in doing, say, if you are mechanical engineer, so since I am presenting a mechanical engineering lab, so let us say if you are a mechanical engineer, you would like to do an experiment on heat transfer. So those experiments might not be available in mechanical engineering, but those may be available in physical sciences. So one has to just have to look after, you have to go through each and every discipline. You might find your lab somewhere else. So virtual heat transfer lab is available in physical sciences. Similarly, there is a like sensor modeling lab is available in electronics, that is belongs to instrumentation engineering. Network theory lab is available in again electrical engineering, so that may require for the electronics. So there are a lot of interdisciplinary approaches, and labs are available in different location. So those if you are not able to find a particular subject in electronics and communication, okay, just go through, find in electrical engineering, it might be available. In computer science also, some of the microcontroller labs like those kind of things are also available, which is actually part of maybe for electronics. Okay. Then there is a second tab, that is VLabs Dev. Now this VLabs Dev is basically a community portal. Okay. So all the community effort goes into this VLabs Dev. Now, one of the fascinating thing about this VLabs Dev is all the experiments which are posted on this VLabs Dev are compatible with mobile devices. That means you can perform all the experiments which are on VLabs Dev on mobile as well as on desktop without any plugins, without any requirement. iOS, Windows, Linux, any devices, you can perform all the experiments which are hosted on a VLabs Dev. Okay. So in Explore tab, there are two categories: approved lab and lab under development. So lab under development does not mean that it is in a development phase. Actually, it is in a testing phase. So once you develop a lab, there is a rigorous review and testing phase through which each and every lab goes. And for that purpose, that lab is available in the under development. So all the labs which are being posted under development are good to go to conduct the practicals. It's just some 3-4 month testing period is required once it has been done, and therefore it is posted under the labs under development. So I go with the approved lab. Okay, so this is the numerical method lab which I developed. Okay, so I just go hit and explore. So this numerical method labs is directly mapped with the most of the engineering branches: mechanical, civil, chemical, electrical, and now recently electronics. This lab is of higher cognitive levels. As Naruna sir already told you that there are 6 levels what we have to go through it while teaching and learning process. That is starting from remember, understanding, apply, then analyze, create, and evaluate. So once the student knows how to solve, okay, so that apply level is reached. Most of the questions are find, solve in this level. And if you have a questions like compare, analyze, okay, find the best method, create something on your formula. So if that you are looking after, then this lab is built for that thing. You roots of equation bracketing method. So here you'll find A, and then you have a short theory algorithm of two bracketing methods, that is bisection method and false position method. One numerical example is been shown by both the method how you can solve it. C program is also available. At the same time, MATLAB program is available. Just to, if you want to have a rigorous and high computation on your side, because those are iterative processes. So rigorous computation cannot be done on web application. So if you want to do it, and further if you want to enhance this, those things are available. We have a pre-test question as already been explained. So these are the same thing. What are the pre-test questions are available? We have a procedure where a detailed procedure is explained. And at the same time, there is a video also available. If I click this video, you'll be launched to a YouTube channel, okay, where the a bracketing method, how to perform the using a simulator, that is been explained in this one. So lots of help is provided so that this becomes an independent system, so that student can learn on its own pace with the whatever the help and guidance is provided on the virtual labs. I hit the simulation tag. So here all the three tasks has been explained: task 1, task 2, and task 3. And at the same time, there are many more tasks available at the post-test question. Okay. So these are not only the tasks what this simulator can solve. This simulator is a generalized simulator. If you know, Ghosh ma'am and Priya ma'am explained you how you can do the randomization variation. You can set up your own question, different kinds of question, different question to each student. And you can use this tool whether the student has solved correctly or not. This is one of the effective way for assessment, also for providing a student a better visualization and how you are going it. So first task is simple, to find the root of an equation. So in this way, you put the equation, enter the first initial guess, enter the second initial guess. So here expected, what is that? The student knows this method and student understand how to solve it. That solve level is there. And now we want to reach it to analyze, evaluate, and create level. So he is not able to do all manual calculation, just hit solve. A solution will be available by bisection method, false position method. How the function is varying, that will be explained here, that what are the function you have inputted. Now here in this case, the comparison of both the method, how those two methods are actually approaching towards the root of an equation. Now you can do a lot of kind of analysis questions here, that whether which method is having to and fro, which method is converging faster, okay, which is giving best accuracy in less number of iteration, which is having a lower computation time. So these high cognitive levels are very difficult to track in a classroom and in normal teaching hours, because it's a time consuming as more number of data generation is required. So it's a repetitive calculation. Use computational tool, allow them to use it, and try to reach to this higher cognitive level question. And of course, there are questions like x square minus 4x plus this. So these questions are very tricky questions. I suggest you to everyone, those who are from this field, just try to grow it. Okay, the purpose is not to find the solution. Okay, purpose is something different. So it should reach to a higher cognitive level. If I put it, this equation seems to be very simple. The root is known to everyone. Right from the 5th standard, everybody knows the root of an quadratic equation, x square minus 4x plus 2 is 2. And if I hit solve, I do not get a solution by bisection and false position, but I do get a graph. Okay, and here students are able to find out because of this graph. This is because I'm getting a full behavior, full picture. Okay, student can now justify, okay, why I am not able to get the root of this equation, why this method are not feasible to find this quadratic equation. Such kind of questions are very rarely dictated in any kind of classrooms and practical teaching. That's what we can take the help of here. Similarly, there is a practical example like velocity of falling parachute. So it's a step-by-step increment. Okay, so you can attempt those two. So I quickly go to the post-test question where the strength lies here. Okay, so one has to observe the question is not how to solve. Okay, question is at higher cognitive levels that the function, this is what is the function given to you. Initial guess are 1 and 3. So one important thing, whenever we provide this all this method, we provide the solution initial guess to the student. Okay, but let's say we don't provide it. Okay, he's not going to get the solution, but he will never realize why I'm not getting a solution. But with the help of this graph, if he knows the method correctly, from this he understands that I have to move up. Okay, I have to move up to reach to intersect the x-axis, and therefore this 0.5 is not enough. Okay, so here he can play, he can understand how to, what are the initial, how to provide the initial guesses, how to select the initial guesses to solve a problem. It's not always that when you encounter the practical problems, all the initials and boundary condition is given. Okay, you have a problem in front of it and you have to solve by putting certain assumptions on your side. And this is what is going to help you in that regard. So I go into quickly post it. If you see all these questions, okay, here initial guess 1 and 3 is given. The question is not to solve. The question is which method gives root of this equation in lesser number of iteration, and the root of the equation is 2.25. The answer is given. Okay, here you need to compare, you need to analyze, you need to go for the evaluation stage, that which is the best, which is the faster method. If you scroll down, all the questions which are been mentioned is of very high convergence level, like which method has the fastest conversion rate to find the equation f of x minus cos of x with initial guess so and so. Okay, then which method gives highest accuracy to find the root of an equation exp minus x. So this is one of the fantastic example that everyone says the false position is faster. Okay, so always there are some exceptions. So this is one of the exceptions question which I can show you how to solve. So I can put 0 and 1. And if I hit solve, you could see bisection method has achieved a very high degree of accuracy. Okay, so you could also see that how you are able to do it, because it's a what you say exponential curve, and the slope of that particular what you say false position method very slowly decreases, whereas bisection method is having to and fro method, and it directly reaches to the, or it reaches to the in lesser number of iterations. So that's all about the numerical method lab. Okay, so I just go back to the list of the experiments. Okay. Okay. Sorry. So there is some link broken issue. So things keep on changing. Okay. Approved lab, numerical methods. So these are the list of experiments which is available. So almost all the methods has been taken care. Okay, and second part will also be available soon. Now I go to another lab. Basically, that lab is from the lab name is strength of material. So which is applicable to both. It's in an underdeveloped lab, both mechanical and civil engineering. So here the approach of strength of material is different. If you go for PIC lab, you will normally find UTM testing and all those stuff. So those kind of lab is also available. It is also named as strength of lab, and that is available in civil discipline. But here I would like to show you one of the lab, which later on I'm going to talk about this. So This is the strength of material, which you can use as a basically while online teaching purpose. So here I could show a list of experiments. And first example I'm going to show is this bending moment and force. Okay. So again, I'm not going to show theory, pretest, and procedure. I'm directly going to hit the simulation. Okay. So here again, some two questions are there. Question 1 and question 2, something like is there. So those are not the only limited question. These are the question just to try out this lab. Now you can set on your own a different sets of question, and this simulator is capable of solving that question. Okay, it's not only those questions. So even numerical method, you can also set up your own question, okay, and you can solve it with the help of that. So here some question is there. So I just do not follow this question. So I say my beam length is 1 meter. So let's try out. It solves a different question. Yes, it has shown me 1 meter. The question was different. Okay, it's not necessary. Okay, you can try in this way. You can set up your own question and let the student know, okay, you click on question 1 and solve my question, no issue. Select the number of forces. So I can hit 2. So immediately it will be available 100. So I put some values here in this case. So I put 0.2, okay, 0.2 meters. Let's say put 200, maybe 0.8. Okay, something like this. I will put the value and then submit button. Okay. So now for this, immediately reactions are available. And now you have to start building a shear force and the bending moment diagram. Okay. So put the shear force. So student will put 1. So let us say I put 100. I do the mistake. Okay. So it will say verify, oops, your answer is wrong. So that means here step by step, what we are missing in online teaching is the step-by-step assistance to the student, whether at this level I'm correct or not, at this level I'm correct or not. So here each step is made to sure that they follow a correct procedure and correct step, and then they move ahead to final solution. So instantly he will do rechecking and all the thing. Okay, if he still not getting, if he keeps on trying, after 3-4 times, he will show you, okay, you are not able to do it. This is what is the answer. That option is also available here. So verify. So 120 is correct. Okay. And then second stage at second point at this location is also a 120. Okay. Then of course I have to subtract, let us say 200. So it's supposed to be minus 80. No. So 180. Okay, 100 I have to minus, sorry. So 20. Okay. And of course, once I got the 20, then rest of the thing I can put down the value. This will be also 20. Okay. After 20, it will be minus 180. Okay. And finally, it will be minus 180. Okay, so now all the answers have been correct. It is a step-by-step calculation we have done. It's a different tool. Okay, so it's not virtual lab. It's not about doing or representing the actual physical, what to say, representation or conversion. You can easily use this as a your teaching assistant tool for your classroom teaching also. Show the shear force diagram. So immediately, since all the points we have calculated, we get all the shear force and diagram. Similarly, now we can start going ahead, calculate the bending moment, each and every location, and you keep on solving the step-by-step procedure. Now this procedure is very long, so I'm not going to tell you. You can try on your own, follow all this procedure, and immediately you will also get a bending moment diagram. And of course, you can hover the mouse on your that particular graph. You could have all the values available, and on these values you could also ask the questions, okay, which could be at the analyzed level. Okay, so that's all from my side. Thank you for patience listening. Meenal ma'am, over to you.
Thank you so much, Nagoshi sir. Now we have one more demonstration. So I'll just share the screen first. So now we have Professor Tanuja Khatavkar. She's a regional coordinator, Pune, VLabs PVG, VLabs IIT Bombay. Before that, she was a nodal coordinator, and she's the, in fact, both Professor Tanuja and Nagoshi sir, they are the one who are playing key role in all these VLab activities for this entire region. Tanuja ma'am, she's a professor in electronics and telecommunication. She has herself developed few labs. She is mentoring on the national level for development of the virtual labs. So today she's going to demonstrate few labs which are based on digital application and digital logic design. Even though it is mentioned in this slide that the disciplines to which it maps is electronics and telecommunication, but I would like to mention here one more important thing is that whatever are the labs she is going to explain, those are equally mapping to the disciplines like computer engineering, where they have a subject called as a digital electronics, and information technology, where there also they have a subject of digital logic design, even for the electrical branch. So over to you, Tanuja ma'am.
Yes, thank you. Thank you, Minal ma'am. And yeah, I'll try to share my screen. Yes, good evening, everyone. I know it's high time and we are marching towards the end of the sessions. Yes, for faculty to be so patient, and listening for all these hours, it's really very difficult and taxing. I do understand. But yes, now we feel that virtual labs, every teacher should know how to use it. And these teachers in turn are going to teach their students or help their students to learn the subjects in a much better way using some ICT tools. And what I'll do is quickly I'll go to, just because we are trying to cover at least one experiment from different disciplines. Okay. And at the same time, we would like to give you the flavor of the different ways the labs have been created. So I'll just go to VLabs Dev. And here on VLabs Dev, as we have this one, approved labs, we have one particular lab, which is a fundamental one, that is digital applications. Why I'm going to explain this is, you'll appreciate that even a simple logic gate fundamental could be delivered to a student in a very interactive way. The very idea of using virtual labs is, or giving this tool to the students as a self-learning tool is, they should understand how effectively this interaction could happen with the screen in front of them. And someone is guiding the student throughout the experiment step by step, and he can learn on his own. This is what the pedagogy goes behind it. The efforts of the teachers who develop these labs along with the students really are commendable. It's not because we have been doing it, but we really are in a position to appreciate because we have worked on it. And these are the fruits that we are looking at right now, that we have of the seeds that have been sown by the faculty and students of PVG COET, and also all the participating institutes who have earlier developed the virtual labs. And with due regards and respect to all of you, I would like to show a glimpse of, let us say, digital applications. This is a lab that has been created. Look at it. It just has AND gate, NOT gate, NAND gate, NOR, XOR, and so on. And it's not the gate that has been given, but some analogy, some application related to that gate has been developed. A washing machine control using AND and NOT gate. Or you can say industrial control application using OR gate, right? So you'll find 14 experiments. Out of these 14, first 13 experiments, you'll find simple examples given there, and then you have do it yourself as a 14th experiment out there. So I'll just demonstrate quickly. Yes, in the faculty orientation workshop, I did get an opportunity to talk to the teachers from digital electronics background about these labs, but those who have missed on it, they can have a look. And those who are from other streams, they could also look at the way it has been developed, and that could somehow you may be able to relate it to how you could come up with your subjects and labs related to it. So for example, I normally take this example for car wiper control being a very simple idea that everyone can immediately relate. So instead of teaching the student what that AND gate is, yani ki, what is the truth table of the AND gate, why not give him in a very different way? So as we have a lab manual for each of these experiments, we already have gone through. I'll just quickly scroll down to show you what are the contents in the lab manual that have been taken. And at the end, the application, that is a car wiper control, which has been showcased out here, assuming that all the sensors are digital in nature, they're going to give me a 1 and a 0 as the signals, you can say. The concept has been shown over here. This will help the student, even a first year student or a 12th standard student also, to visualize and to relate the logical function, which is AND. So if it's a car wiper, for example, it's going to have something like a ignition switch and a wiper switch. So we know only if the ignition switch is on and the wiper switch is on, A and B both are high, the wiper is going to move. How is this demonstrated to the student? So as we normally have, we have a pre-test wherein I would just like to show some questions to the student. Okay, let us check whether he has some fundamentals associated with that particular subject or not, or certain points which I want him to know. Those are going to be there in the pre-test and the post-test. This is the first lab that myself and Nagosha sir, we came up with at PVG COET. And there we started, this is a procedure page, by the way, this is a procedure page. And you should follow the procedure that has been given there. Also below, you will find there's a link, okay, which will help the student to see how it could be used. Now, let me go to the simulation page. On the simulation page, you do have the pop-up procedure here. Just in case you missed early what was the steps, you can do it here. But normally, we do not need to go to the procedure page because they're very self-explanatory type of experiment. Look at this, a very simple way of demonstrating the AND logic. This is the AND gate over here. And it has got two inputs. One has been labeled as ignition on and the other as the wiper. And then we have the motor, which is going to help the wipers to move on the screen. So everyone knows if one of the input is high, obviously it's not going to turn on the wiper. But if both A and B are high, that is the ignition is on and the wiper is on, then you'll find the wiper is going to move. Yes, so I hope you could hear that audio as well. So we tried to attach that audio and we have some visuals. This is not animation, okay? This is not animation. This is programming that has been done at the back end. You have a proper framework of logic gates that has been developed and that is being used in this application. This was the first part of the our development process. We just came up with this demo model. And then we realized, is the student really learning by just clicking here and there, okay, on the buttons? Is he really learning? Yes, in the first case, he's able to relate, the fundamental of AND gate to a real world scenario. But what additional can we do? So next started the development phase. What we tried to do is then we modified the lab. It's not only about creating the lab and just hosting it. That's the end. No, you have to keep on updating the lab, keep on changing the cognitive levels that can be achieved using the lab. So what is done later stages, we came up with a generalized simulator of two input type of gates. So here you'll find in two input type of gates, you have a blank canvas and the student can pick and place the components. Suppose he's going to, let me show it, one at least. So he clicks on the AND gate. Here it's prompting, place the AND gate. Just see the beauty of the way it has been coded. And then let's say he's going to connect two switches to it. So there are digital switches which have been provided out here. I'm going to use these digital switches and place them on the screen. So that's the first switch. And let's say that's the second one. And then let us say I'm going to use a green LED at the output. I'm trying to mimic what was shown in the first case. Use the connectors over here. How to connect them, which connectors, wires are to be connected. That you can see from the video as well. Once you understand that, you can quickly use, the students can quickly use this tool. Now, how can a teacher use this particular tool for online teaching learning? Yes, that's the best thing that you can do. Why I'm showcasing it again here is for online teaching, this is going to be a best tool, I must say. It's not only for the lab work, but also for the theory part, teaching of the theory part. Now, what I've done is I have connected it. Let me start the simulator. If I start the simulator, and now I have set this as 1, it's turned green. Look at the beauty, these wire has gone live, okay? And if both of them are on, yes, the output is going to be high. Now, is this the only thing that the student can do? No, it's a generalized simulator that has been provided. So a task has been given to a student, okay? Now, is the student able to, it's not only about recall level and understand level, is the student able to apply what he has learned? What is done is a task has been given over here, okay? And he is supposed to now, design a majority type of circuit using it and verify the result. This task is just as a sample that has been given. You teachers, what you can do, you can give a problem statement of any real world scenario, which can be developed using any 2 input type of gate, AOI logic and or invert logic, and ask the student to design, get a screenshot and submit it to you on Google screen. So in this way, we have different 14 experiments. So I think the teachers can just go through the different experiments that have been given over here. But this was the first lab that we came up with. I just wanted to see to it that this could also be used as a teaching learning tool. So what we did is we tried building another labs also, other labs again on the same concept of digital, but taking it a bit, one step ahead, I can say. Do we have Harshada online?
Yes, ma'am.
Yeah, quickly, Harshada, can you please take the screen? I'll unshare.
Yes, ma'am.
Yeah. And Harshada is one of the students, one of my students, Harshada, Shubham. Then we have Nagoshi sir.
Hitesh.
Yeah, he's sharing. Yes, Hitesh. Yeah, I was just checking whether she's able to share or not. We have Hitesh, Satyam, and Sankar. All these students, they were working with me on this particular lab. Yes, quickly, can we go ahead? So
yes, ma'am.
Yeah, I think it's 3:55. Yeah, she's trying to show you one more, that is digital logic design using gates. And
the first experiment.
I'll just explain. You can just click on design of multiplexer. So here the aim has been suggested. The students will be able to select appropriate gates to build a multiplexer circuit, okay, to identify the role of a multiplexer circuit, and to design, construct, and verify the operation of a 2:1 multiplexer using basic logic gates. So these 3 things are as the outcomes that we're looking for when I'm designing the circuit. Yes, can we go ahead with it?
Yes, ma'am.
I think we can directly go to the simulator. People during the hands-on, they can go through the other things of the lab manual. Yes. So what has been done here is, yeah, scroll. There's a quiz initially, to for this particular multiplexer. Yes. She has started the quiz. And there comes the first question: which basic logic gate will you choose on inputs of a 2:1 multiplexer? I'm trying to check whether the student has, knows the concept behind it. And then he's going to answer that question. Give a correct answer. She says AND gate and she submits that answer. Yes, that is correct. Hence it's gone green. Go to the next question. Yes, the next question is about, which gate would be used to select line 2:1 multiplexer. Give the answer. You may give a correct answer because we have less time. Yes, check the answer and go to the next. Yes. Next question is about which basic gates would be used to choose the output of 2:1 multiplexer. The student is going to answer. So it's interactive, the screen is asking some questions to the student and the student is answering. It is not about MCQs. Let me tell you, it's not about MCQs. I'm trying to check whether he knows the concept behind it. Yes, can we go ahead? Right, just a minute. Look at it. It's given me a pop-up saying your score is 5. Why? Because on the first hit itself, I could give the correct answer. So the student is motivated. Yes, I've got a score of 5, right? And if he's going wrong, he'll get a score which is -1 each time. Yes, we can go ahead. So that he has completed the first level, he goes to the next one. Proceed to the next stage of the simulator. So you click on next stage. And now let us see whether he has understood the function table, of the multiplexer. So here there's a question. What will be the value of the select inputs S2, S1, S0 to get orange juice? Yes, please click the answer, click the answers. So if he has understood the function table, he'll be in a position. Bingo. She's given the right answer. So it gives a message saying bingo. So that's again a motivation. And it says, please read the next question. So these interactions happen and keep the student, occupied, or you're engaging the student for all the, throughout the experiment. The next question is about selecting the inputs for, again, red juice, for example. So she selects it for red. Red is 6. So it is 110 that she's going to enter. And yes, bingo, she's got it right. Otherwise, it's going to deduct the marks. Please read the next one. Yes. Now that was about the select lines. Now this question is in a different way. Here the value of S2, S1, S0 is given and he's got to answer. Select the juice. Yes. So if it is 0, 0, 0, it's violet. Yes, that's right. And then next question, correct. I'm going a bit fast. Yeah. Okay. And here comes two questions for each type we are giving, and the student will be, so now we know, yes, the student is in the position to answer his scores, or even he is able to check that he's on the right path. Can we go ahead, Harshada? Yes. Now, let's look again at the function table, like the way that was done in a slightly different way, so that the understanding is made, so that he understands the concept. Let's go and make it more technical, showing the truth table, the function table. Yes, you can complete that task, Harshada, please. So if enable bar, if it's not enabled, obviously output is going to be 0. And if it is 0, output is D0 and D1 and submit. So on the right-hand side, he has the mux representation. Look at the scorekeeper there. The scorekeeper is telling your question 1 has scored, you've got 5 marks for it. Yes, can we go ahead? Click the correct Boolean expression. I'm trying to check whether he's in a position to also identify the Boolean expression that is there. Yes. I'll ask her to give correct answers in this case because we have less time. Yes, we can go ahead. Proceed to the next step. Yes, that answer is also right. So has scored 515. So you can go to the next level now. You're trying to take the student step by step. So he should not look at the blank screen, what has to be done. Okay. So here we are guiding him. Yes, can we quickly take this experiment, Harshada? Yeah, she's trying to build a circuit. Again, you have a canvas over here, which is now available for the multiplexer. Now, this is not a generalized one. This is for the multiplexer. So that is going to verify the function table, which is he created in the earlier session. On the right-hand side, you have the function table, so that he or she is going to build the circuit and is going to verify. So isn't it a self-learning tool in this case? So the teachers can think about their subjects, and yes, she has used a Y connector out here. So whenever a single connection has to be made to multiple points, we can make use of this Y connector. Because when you code it, we need to take care of all these aspects. And each time you'll find on top of the screen, it's telling, select second connection is completed. It's guiding the student throughout. So you could also explain this in the online teaching also. You could show it this way or ask the students to do it, perform it, okay? And learn. Yes, you can simulate and show the results. Harshada? Yes, okay. So D0 is 1, output is 1 because she has enabled it. And now D1, yes, you have got to select it first, enable it. Yes, that D1 is 1, output is 1. So in this way, you could show it to the students, or you can ask the students to take up these labs. So these would be useful for both the fast learners as well as the slow learners because it's guiding throughout the session. Thank you, Harshada. Thank you for quickly doing that for me. Yeah.
Thank you, ma'am.
Students are very, very smart. They are very quick. They pick up so quickly. And let me share the feedback from my students that they have gone through this subject in second year. She is now in third year. So when she was in second year, she has developed this particular these labs with me. And she has also got a platinum certification for it at RC Banda. This entire team, I appreciate them. I really take this opportunity to appreciate the teamwork of the students, along with the faculty. And that's how we could come up with another lab. Just give me a second. And but our SENTC syllabus, if you look at it, we have the experiments based on, we have the experiments that are based on ICs, so the trend that we have taken is we started with small scale integration, SSICs, then we went to MSICs. Now MSICs, when I'm, yeah, you'll find one more lab out here. Why I'm showing it? So that you know the complete package which is available. Just a second, let me scroll. Electronics, logic design, yeah, digital logic design. This is a final year project of IT students. I'll not demonstrate here, but I would like to show you the scenario in the simulator, so that you are aware, yes, something type does exist. I'll just wait for a second. Okay, so I'll straight away go to the simulator. Well, the experiment was about implementation of 8:1 mux using MSI ICs. If you look at the list of experiments, by the way, you'll find all these experiments, they are there as the first 4 experiments for your digital electronics syllabus. Okay, so faculty can outrightly use these labs, ask the students to use it. Why? Because it's going to help them to learn the subject very effectively, or you can deliver the contents very effectively. The videos and everything is provided. Now, this is a scenario where, where in colleges, if they have a digital trainer kit, they can use this particular way to demonstrate. Okay, if you directly give this particular trainer to the student to handle, you may feel there is nothing much in it. He just has to click on, the inputs, select the inputs, turn on the power supply, and set the values and check the output. This is what you may feel. Well, that's not the case. It's the teacher's skill, how he's going to deliver the content to the students. How did I go? I went with the first lab and then the second, and then I came over here, that he knows what are the internal gates, how do they function, how I can use, in designing certain applications. Now let him use the ICs. Now the beauty of this experiment, I'll just show, I won't demonstrate the experiment. You can do it during the hands-on session, is it also has a timing diagram out here. Okay, there's a timing diagram here. So if now the inputs are 1, 1, 1, it's a multiplexer. If I switch my input 7 as 1, after switching power supply on, the output is going to be 1. So let me capture this, I can capture the timing diagram. Can you see that? And if you are going to stop it, you're going to change the input and again, ask it to capture, and you'll get the timing. So the concept of timing diagrams also is given to the student. And while doing that, then you can tell them what is this propagation delay, from where does it come, and so on. How to relate what the content is on the virtual lab. It's really the skill of the teacher. And above that, here also the manual for each of these, each of these is provided. The data sheet, I must say, not the manual, the data sheets is also, you can also go and click and check the data sheets, and the student can, it's everything is available, the entire package is available here. I think many more experiments are there. Integrated circuits lab is there. Then you have the network labs and so on. There are many labs, but since we are running out of time, with the permission of all the dignitaries out there, all my faculty colleagues who have been listening to all of us, and the only objective that we have in this entire workshop is we would like to share this virtual lab tool with you people, and you in turn, we wish share it with your students, and we make this learning happen, teaching learning happen in a very interactive and a playful way, I must say, in a playful way, so that students enjoy learning. Yeah, I just take this opportunity to thank everyone for going through this session with me, along with me, and keeping me motivated till the end of the 2 experiments or 3 experiments that have been demonstrated. Thank you so much. Meenal ma'am? Yes. Meenal ma'am, are you there? Okay. So
hello,
let me make an announcement. Hello. I request Nagosha sir to give some inputs, certain suggestions before we start with the hands-on session.
Yeah,
yes,
thank
Nagosha
you,
sir.
Yeah, thank you, ma'am. Okay. So I just share my screen. Okay. So is my screen visible?
Yes, sir.
Okay. So we'll be sharing this Google Docs soon. Harshada, can you post the link onto the Telegram group? So you can open this Google Doc
Yes.
link. Okay, you can open this Google Doc link. So here the links are provided. Okay. So while doing, you might face some difficulties or some queries. So you can click on this link. Okay. Let's say I click on computer IT. This is what is the form. And of course, you have some common problems. So already there is a one URL provided. What are the common problems you are facing? So if you click on this URL, so most of the common problems that you are facing, those solutions are already available here in this case. Okay, so I just go back. Okay, and here you can type your name. Don't type test. Please type your correct name of the lab. So this is for the demonstration purpose. Correct URL. So while performing experiment, if you face a problem, so at this, you can select this and now you can copy this URL and you can switch back to this link. Okay. And here you can paste it. And of course, what are the problem faced, you can post it here and just submit it. And you see, please share your query solution. So here, after some times, we'll be working on the same sheet and you can hit this URL and your questions will be available and the solution at this location. We are trying up from our side best to dictate all the solutions and those solutions will be available at this location. So later on you can try. So you are getting this link on Telegram group. Okay.
Can you just
also I request you to post the chat, post that link in the chat of Zoom meeting also. Okay.
Yes, sir.
Yeah.
Sir,
So,
again on YouTube link also, you have to send that. If you send me, I
yeah.
can
So you, Harshada, you can post on chat, please.
Nagosha sir,
Yes.
I think it's high time. It's 4:05. How much time do we give to the participants for hands-on? Because we also have Pushpadip sir.
20 minutes.
20 minutes. Okay. And we also have to share the PDF, okay, which gives the mapping so that they can use that particular sheet to check one of the experiments and they can work on it. It will be easy for them to access.
Yeah. So Urmila ma'am, can you post that PDF into group, please?
The SPPO virtual lab mapping PDF, please share.
Urmila ma'am?
Okay. I think you can define, sir, you have declared the hands-on session to others?
Everyone can start doing hands-on session. We will be meeting at 4:20 back again.
Deadline to submit feedback or later on?
No, later on. We'll.
Okay.
No, and so that when you're submitting the feedback form, you'll give the name of the experiment that you have performed. You don't have to search here and there. So please note down the experiment that you're going to work on. And yeah. Is it shared, sir?
PDF, na?
Yeah.
Ma'am, I'm sharing.
Yeah, please do. So that they can start. Yeah. In the meantime, I'll request Pushpadip sir to just please wait for a few more minutes. Meenal ma'am, in the meantime.
Meenal ma'am is disconnected.
Sir, can you share that PDF file to me also so that I can upload on YouTube?
Which PDF file, sir?
What are the PDF you are sharing with
Your voice is very low, sir.
What are the PDF you are sharing with participant in Zoom? No? So same you can share with me so that I can upload on YouTube channel.
Yeah, sure.
Or if you are having access, you can upload on YouTube. No issue.
Just a moment, I'll share one more PDF. Yeah, one PPT I've shared.
Meenal ma'am, can you please display the slide? The agenda, you can say, or the proceedings.
Apsangi ma'am is disconnected, ma'am.
Is the screen shared by us?
Just a moment.
So it's showing some different slide.
Mahal sir, I have posted both the links where they have to put the query and PDF document. Okay.
So on YouTube also?
No, not YouTube. On WhatsApp.
So can you mail me so that I can share that on YouTube channel?
Yeah, sure.
Now, sir, is this screen shared by us? Please check it. Otherwise, we have to remove that.
No, sir. It is not shared by us.
You stop this, please. Yeah, check mail, sir. I've sent the mail. Mawale sir, can you make Apsangi ma'am co-host? Mawale sir?
Sir, you can also do as your co-host.
Actually, I'm not aware of how to do.
Okay, from mobile we cannot do.
No, not more. I'm from desktop.
So you can do, sir. You just go to more. There will be more setting options are there.
More start video, allow record, rename, put
Or you go
waiting
to
room.
you go to participants and click on that Apsangi madam. There will be option.
No, there are options like ask to start videos, allow record, rename, put in waiting room, remove. These are the only options.
Okay. And so don't know for it is available only for host or what. Ask to start it. Khatawkar madam, now you are co-host. You can unmute and speak.
Minal ma'am, your co-host, share your screen immediately. Start the session.
Am I audible, sir?
Yeah, you are audible.
Okay. So I hope you're trying or you have done with your some experiments, which is a hands-on session on virtual labs. So this is an important thing which I'm now telling you. That is nothing but how to feel the feedback related to all these experiments, whatever you have done. Now, why I'm saying this is important, because whatever are the feedbacks we are giving directly to IIT Bombay server. And because of that, whatever feedbacks we are getting from all you people, those will be registered, those will be taken care for our later use. So I'm just going to now, what you have to do, again, come back to the same site, which is vlabs.iitb.ac.in. Go to outreach. Sir, are you able to see the screen?
Yeah.
Yes. Click on the outreach portal. This is our main outreach portal. You have to just scroll down from here. And you can see here feedback forms. Now, from this feedback form, for today's session, all the participants, you have to click on outreach feedback. So once you click on outreach feedback, a link will open, and this is actually the registration and the outreach feedback. Make sure that you do all these things properly. Now we will be sharing with you, and of course I'll be telling you right now also, that whenever the faculty members from mechanical, electronics and telecommunication, and civil, they will select the organizing nodal center as 62. Again, I'll repeat, the streams, that is disciplines like electronics and telecommunication, mechanical and civil, they will select AISSMS college as their organizing center, and rest all other branches, they will select 20 as the nodal center, which is a PVG COET for you. I'm just showing you with the help of PVG COET. So let's say I've selected PVG COET over here. Date of the workshop is today's date. I'll just go down, scroll down, and it will be visible, easily possible for me. So you have to just select today's date and then all the participant details. So here it has to be faculty. I think I've missed something here. Participants and participant detail. You can type your name over here. I'm just typing my name. You can just scroll down. Faculty ID, you can specify any faculty ID for you. You have to register with your mail. That is, I'm just typing my mail address over here. Mobile number. You can just write date of birth. Institute name. Now this is very important that whenever you are typing institute name, please do not enter any kind of special symbols, not even a dot or a full stop, not a comma, not an apostrophe or anything. Please do not, otherwise this feedback form won't get submitted. Then you can have an address. I'm just typing your address as PVG COET Pune. Now you can just come down and you have to just write this verification code, which is Z, whatever it is, you will see your verification code different, and you can go and say proceed to feedback. I think I've kept something blank. I haven't selected my department, so I'll just select it. So that's it. And okay, my email address is already existed. Fine. I'll just do quickly. I'm using my other email address. Once that is done, you will come to this particular page. Now this is important. Now here actually we are selecting, here actually we are filling the feedback. So what you have to do, you have to select the user as an outreach user over here, and the labs which you just had a hands-on session. For example, if I am from computer science and engineering and I have done a lab on computer graphics, so I'll be writing computer graphics over here. That is why the message was given to you that whatever the labs you are working on, please make sure that you write it down at their names and everything. I'm just writing it. Suppose there is a DDA, line generation algorithm. Then you can select some other, or if you have done from the same, you can select it from same, or I can write it for some different also. I can see here as a data structures. Suppose I did graph traversals today. You have to mention those. Now, at this point, we are saying minimum 2 experiments, you have to write it over here. So if you have more than that, you can just go on copying in the same way, you have to go on writing it down. If you have added, if you want to add, you can go on adding the number of rows also. Here you have add more rows. If you have finished with all these text boxes, whatever are available. Then you have to write these questions. I hope these questions are self-explanatory. You have to just mention over here what is your suggestion or what do you feel about these. And then there are a few important questions which are what aspects you find interesting, do you had any problems or difficulties and all those things. So all the fields are mandatory over here, and at the end you have to submit this particular feedback. So make sure that all of you feel these feedback. Today itself, this link for the feedback will be available only for the day. I'm again telling you that you have to just go to vlabs.iitb.ac.in. It's go to outreach. In the outreach, you just scroll down below. There is a link. There is a tab called as a feedback forms. Here you have a outreach feedback. Now, just to tell you that what kind of, again, the same things, that is disciplines, which has to, which disciplines should give the feedback on AISSMS portal and which faculties should give on the PVG's college. So I'm just sharing one screen with you all. You will be able to see that screen now. Is this screen available? Is it visible?
Yes, sir, it is available.
It is available.
Yes. So as I said, for ENTC, mechanical and civil, please fill the feedback selecting organizing center as 62, and all other disciplines, please select it as 20, which is PVG COAT Pune.
Madam, if the participants are already registered, so they are getting message you are registered when they will enter their mail ID.
They can put their different mail ID.
So they have to input their different mail ID.
Okay.
Yes, because outreach happens only once, isn't it? So that's why only once that access would be given on that mail ID.
Okay.
Yeah. We do appreciate the patience of all the faculty out here. But that we have decided today we'll understand virtual labs. Let us give some more time to it, and let's complete so that you, when you're going back, you have some good takeaways. You can take a decision whether your college, it's a champion college and would like to be a part of the virtual lab community. Okay, you can take a decision, talk to your directors or principals, and you can take a decision. And next time probably we can have a workshop for all those who are nodal centers and who would like to be a part of this community. Like how to conduct outreach workshops, because we have many nodal centers, but these nodal centers, many of them, they do not go for outreach workshops. So there could be one session on how to conduct the outreach workshops also. So orientation would be given to nodal centers. And at the same time, we have today faculty from various disciplines. You can go back, discuss with the authorities, higher authorities of your institute, and you can take a decision whether you would like to be with the virtual lab community henceforth. Well, if you're not with the community, still then you can use the virtual labs, no problem. Okay, they're free of cost, available 24/7. Okay, they're nationally, internationally accessible. But the moment you become a part of the nodal center, you get many benefits. Now, what I'll do is at the same time, I'll try to talk about my topic, that is about roadmap and success story in a minute or so. Thanks to IIT Bombay team first, because in the morning, Dr. Naruna sir in his presentation already has included the accolades of PVG COAT. But a few things I would like to share as roadmaps to those colleges who would like to traverse the path that was taken by PVG COET to create some milestones in the education community. So if I'm going to talk about the roadmap, what you can do is you can identify virtual labs mapping to your course, utilize virtual labs for interactive teaching learning, classroom teaching tool, train the students on how to use virtual labs, let us say for the ongoing courses. You can give assignments based on virtual simulation of certain fundamental concepts that need to be understood by the students. Then you can also identify a few experiments that are beyond the syllabus. So content beyond syllabus can also be addressed by using identifying 2 or 3, 4 virtual lab experiments and ask the students to explore them. So for virtual labs, they are basically self-learning ICT tools and use them to make your sessions more effective and interactive. And then it's going to learning would be fun and students would be there in your classes or even for the online sessions. Use virtual labs to empower the weaker students by giving them more practice. Now, what we can do is for the, I'm just briefing very quickly because we have less time. Roadmap for community model. You can become a nodal center with Virtual Labs IIT Bombay. You can include virtual lab session in your timetable. I'm just giving you tips quickly. You can arrange virtual lab workshops for students regularly. Then you can go for rollout and you can popularize the virtual labs at your end. You may conduct outreach workshops for faculty from various colleges. Then also, I think you can go for a massive rollout. That will ensure comprehension of the pedagogy of virtual labs. The formative type of assessment that happens in virtual labs, that's very important. So that would be understood when you go for massive rollout. Then establish a student forum in your college and network students with other college students, you can say. You can identify the gaps and identify the lab to be developed and list at least 7 to 10 experiments, and you can propose a lab to IIT Bombay. At the same time, do not forget to motivate your students to be a part of your teaching learning journey through virtual labs. And students can take audit course on virtual labs. Nagosha sir will be talking about the student forum, everything. And students from various disciplines, they can come together, work on multidisciplinary projects in a cohesive way, or a collaborative work culture they'll experience. They'll also have a enhanced peer learning, and peer learning, you can say, and they can accomplish the programming skill sets also. They can enroll for bootcamps and bootathons, and they can join, even the faculty can join, and they can learn the pedagogy, storyboard, the lab manual, and so on. And the students will learn the programming part of it. So in this way, you can be a part of the community model. Once the students and faculty, they get into this mode and they develop a few labs, they get the opportunity of being national virtual lab reviewers. Myself and Nagosha sir are fortunate enough to be a part of this team and helping the community to develop virtual labs. And once your experiments are designed and they're submitted to IIT Bombay team, quality checks from IIT Bombay, very, very strict quality checks. We still are facing, we still are updating with those quality checks of IIT, trying to keep pace with the quality checks of IIT Bombay. And the labs will be published. And the moment the labs are published, do not forget, this is going to be a feather in your cap. It's not a feather in your cap only, but also the students. The students also get a national visibility on the portal of VLabs Dev of IIT Bombay. And this is the biggest achievement that as a faculty, I feel, for a student and a faculty to come up with a teaching learning tool that can be used by the community. So certification is also done by IIT Bombay team once you develop a lab. And yes, keep on utilizing the labs. You'll have to improvise it. You'll have to update that lab. Keep on maintaining the lab is very, very important. And the developers, they get an opportunity, both the students as well as the faculty. My student team has been, they have been traveling with us also as a resource person to different bootathons. I think Nagosha sir can talk about it in his talk about all the different events that we have done. Okay. And yes, you get an opportunity to mentor with new teams and, and work with multidisciplinary groups, networking with virtual lab community. When you come as a regional, when you become a best performing nodal center, you get an opportunity of becoming a regional center as well. And the moment you become a regional center, you start interacting with the regional coordinators from, let's say, Aurangabad, from MSU, Gujarat, or they can be from Mumbai, and so on. So we have so many regions now created, with PVG COET being the first regional center in the country designated by IIT Bombay. And talking about the accolades of PVG COET, yes, today 125 plus experiments have been developed by faculty and students of PVG's team. And nearly 13,000 students and faculty have taken hands-on sessions, and nearly 1 lakh usage has been created approximately by alone PVG's Nodal Center. Nodal Center, I'm saying, not regional center. Regional center is 3 lakhs approximately, the usage. And during the lockdown, our students and faculty have made the best use of virtual laboratories. And more than 7,000 plus experiments were explored by the students during the pandemic. And yes, this is from my side about and how to become a nodal center. The champion colleges, the principal or the director sirs there, they can send us a request email regarding that they would like to be a nodal center, and we would be processing as a regional center, we will be processing that. And IIT Bombay, when they approve as per the norms of expression of interest, you start functioning then as a nodal center. Okay, that's a simple way of looking at the scenario. And only when you become a nodal center, you can be a part of the development team of IIT Bombay community model. So that's the criteria that we have, that you have to be a nodal center so that you can also come up with new labs. And with this, I won't show the website because I'm not able to access the screen right now. So that's what I would like to appeal to all the faculty. Just give a thought how best you can utilize this ICT tool for your teaching learning and also for the teacher students benefit. Yeah, thank you. I think Nagoshi sir, you can take ahead the session.
Yeah, sure.
So that we can have Pushpadeep sir immediately for the next.
Yeah. So I'll share my screen.
For interaction. Pushpadeep sir would be interacting with everyone.
Okay.
So though he is not keeping good health, Pushpadeep sir has managed to join the session. Yes, sir. You can proceed.
Nagoshi sir, just 1 minute. People are asking what is the college? College is your, which I am from. While feeling the feedback, I have written over there as PVG. It's not the PVG for everyone. It's your college. Thank you, sir.
Is my screen available?
Sir. Yes, sir, it's visible.
Okay, fine. So today's topic, again, we are meeting how you can use virtual lab as a teaching assistant, and few things I would like to talk about VLab digitizer. Okay, so just I quickly go through my slides. So this is what we are doing in online mode. Okay, so faculty is telling from one side all the things in online mode transferred as a information rather than a learning content to the students. And of course, you could see what are the various questions are coming in the mind of the students. Okay, so obviously they are facing a lot of difficulty, and also in this pandemic situation, we don't have any kind of choice to go online. Okay, so we have to find a way how we can improve this communication in online mode. How to make them feel that they are sitting in a classroom. How do we provide assistance to them? Okay, so virtual lab is one of the effective tools which you can use in this online platform. So what's missing in previous case is the interaction of the student with the faculty. Students are not following us to perform any actions. Okay, that is one of the important thing. Doubt solving, easy step to perform calculations, detailed elaboration of some other topic. It's like to every batch, they may face some sort of difficulty, and for particular topic, they need detailed elaboration. Okay, that we came to know when we interact with the students. Okay, this batch needs additional input towards this, or that batch needs additional input towards that. Okay, so these things are missing. Step-by-step solution and assessment. Here we give the problem and solve it. But in classroom, generally we do step-by-step assessment, that we first find out this, then this. Okay, so those things are missing. Okay, and that is why there is a big challenge while conducting the online teaching. Yes, with virtual lab, you can provide various questions to the students. It's help in solving the problems. They can verify the steps on their own. Okay, that's what you can do with the online teaching. You can take this platform, share your screen, show them how the steps are going, and teach them all the aspects and fundamentals. Then with addition of this virtual lab, you have an increased interaction with the simulator. So student will be interacting with the simulator. They will be understanding, okay, here I made the mistake, here I have to do the correction. So those interaction will come into picture. Of course, it won't be exactly like mimicking the classroom, but of course, there will be increase in interaction. Step-by-step solutions and assessment and the various corrections are available. Visual representation of the solution, that's the most important thing, which we could utilize. It builds the confidence in the student to solve the problem and work independently. Generally, students are working in group, okay, and they take the help of something brilliant student, how to do this, how to do that. Okay, so that gap here you can try to bridge it, because here now student is alone. Okay, and they can work confidently, work independently on this, and that helps to build their confidence. Most importantly, they can learn on their own pace. That's the most important thing. Okay, so everybody has a different learning pace. Here we can utilize it. Ideally, we would like to get provide different questions to the different students of same cognitive levels. If we try to do it, so it's a big challenge for us, because so many variations we have to solve, we have to find the solutions, and that's becoming a challenging job. But with virtual lab as a set of tools, as you have known, that you can easily use to get the solution of various problem with the help of this, and because of that, assessment also becomes a lot easier in online mode, and you could also give every student a different kind of problem. Higher cognitive levels, that is very difficult to dictate in a classroom as well as in online, because it involves lot of calculations, lot of data generations, and we have a limited number of time, maybe 1 hour lecture or 2 hour lecture, and that is one of the reason we may not be able to reach analyze or let's say create or evaluate level type of questions, because the process is time consuming and we have a limited space of time. But it's only about doing the repeated calculation again and again to generate the data of points. Okay, and for that we can take the help of virtual labs. So what's missing in classroom? We show the graph in the classroom, and we say what is the order of polynomial, how the function is decreasing and increasing, does it have to and fro, what is the overshoot, let's compare this, which is better or best. So this is what we show to the student on the classroom. All these activities are performed by us, and therefore all these activities transform as the information to the student and stored in a memory bank without processing it. Okay, so now let's with the virtual lab, you give him a problem statement. Okay, let's use the virtual lab, process it on its own, generate the data and store it. So this is what you can do to dictate the higher cognitive level questions. Similarly, for evaluate, best, fastest and conversion methods. So all those kinds of question in evaluate, we dictate, we provide the information to the student rather than student processing it right from the data generation and evaluating the best processes to be selected, maybe for to design the process or maybe to solve the problem. Again, processing is absent. Here in this case, again, you can fire a question because the extraction is possible from the student side, because all the things he has taken care, storage, data generation, and the process. So all the three things has been done by the students, and therefore the extraction of this information could be easily done by the students. So for create level, I give you one of the finest example. Design, construct logical circuit to solve a problem. So you can use this virtual simulator, which is provided. Many of the virtual lab is having a generalized simulator where you can have a certain guidance or maybe a problem definition you can give it, and student can create on their own solution for that. So that is also one of the feasible solution to achieve the create level. Most importantly, it helps you to also build interdisciplinary and multidisciplinary approach. Here you are not limited to teach only mechanical engineering. Okay, since I'm from mechanical, so I'm talking about only mechanical engineering. Virtual labs are available from all the disciplines. So if student faces a problem and if you want to explore the lab from other disciplines, why not? He can promote this activity. This will help interdisciplinary as well as the multidisciplinary activities. What it does, I won't say a mechanical engineer would become a champion in electronics, but what it facilitates better communication amongst the student from the various disciplines. So from the various disciplines, students can come together, form a group, can create a wonderful multidisciplinary project, which I am trying from so many years, and that is happening at our end. So you could combine, you can create a project from by using electronic student, from combining mechanical student by computer student, a wonderful project you can build it, and this facility and this communication promotion could be easily established by the virtual lab aid. Of course, we are talking about content in the syllabus, content beyond the syllabus. We can also think about content beyond curriculum. We can also say this could become also part of project-based learning. So all these activities we can easily do with the help of virtual labs. And I quickly go to other benefits of virtual lab. So there are so many benefits. You have to just go through it and put your brains into it, and you can find a way how you can utilize the virtual lab. These are some of the ways which I am talking about. You could select new experiment in the curriculum. So you might go in virtual lab and you see, okay, this is what is the experiment which is not in our curriculum, but this is a good experiment and it should be there. So that idea you can get it. You can get ideas for development of new labs. Like let us say you introduce a new syllabus recently in maybe electronics, they introduce a syllabus of numerical method. Okay, what kind of experiment I should do it? Already numerical method lab is available that you can utilize, and you can think about, okay, these experiments can be utilized in for this new subject. Student can perform experiment multiple times. So we all are passed out our degrees by performing a particular experiment once in a life. Let the future student allow to perform the experiment multiple times. So virtual lab provides that platform that he can do experiment on his own 24/7 at any time. It builds the confidence in the students, especially students from the rural areas. So they are afraid to touch the equipments. Let's do them virtually first. That will build their confidence. Better visualization, what happening inside the physical experiment. So this is one of the fantastic things. We cannot see what is happening in the physical experiment while performing actual experimentation in lab. Here in virtual lab, you have the opportunity to visualize what is inside that. So that visualization you can bring out in a virtual lab. You can have ME project, research in virtual lab at PhD level. Virtual lab is not a substitute to the physical experimentation. It is rather to promote performing physical experimentation in more better way. Finally, we don't want a engineer passing out by doing virtually everything. So we have a digital VLab Digitizers Forum. So it consists of 148 students from PVG COT, and plus they are contributing at various levels. So these are some of the glimpses of students from our side. How they are functioning. So first year students, they get selected through interview process. Second year student goes into development process. So when Harshada was in second year, she was in development process, documentation, and tutor to AFE. So they are responsible for guiding the students and doing the stuff. Third year students, they are all doing internship with the IIT Bombay or various other academic institute or industries, mentoring SE students how to conduct the classes and solving their difficulties in various other programs. Of course, they are also involved in learning new technologies. Final year students, they are the actual project managers, heads of all activity, mentor to the TE students, and they are the resource person for various boot camps and bootathons all across India, what under the head of IIT Bombay we are conducting. For VLab development, we are training the students in technologies like HTML, CSS, JavaScript, TypeScript. Presently, this same course is recognized as an audit course under Pune University itself. 2 years back, we introduced this course as an audit course. Training is given by the student for the student, open to all engineering department and field. No restriction who can take this course. Okay. Finally, programming has to be done to solve the engineering problem. And if ENT student knows one programming language, he is in a better position to solve or build the labs, which is in the field of electronics domain. Technology studies are, again, I'm repeating the same. So they are get acquainted with MySQL, SQL Server, PHP, Django. They get opportunities with internship, Android and Java programming app for app development for mobile application, Python for machine learning projects. Because now, what are the future labs are coming? Presently, you might be seeing that some of the lab involves lesser time to complete the experiments. Okay, but now within a 15 days or 1 month, there will be fantastic lab coming from physics, chemistry, from management, from biotechnology, biology, and heat transfer area. Okay, so those labs will be involving students for more than 20 minutes for one experiment. Such a high level labs are now soon will be coming. And of course, slowly, intelligent lab. Artificial intelligence is going to get into a virtual lab to find weak student, strong student, where he is facing a problem, how to detect that problem. So this intelligence is going to come into a virtual lab slowly. Of course, Arduino, Raspberry Pi, all the electronic stuff need to be required, and while as the various designing softwares. These are the opportunities what we are getting it through all these forums. Internship opportunity for contribute to virtual labs initiative by IT Bombay, because there is a portal, there is the statistics, okay, there is a management, there is a learning system, and these has to be handled. And for to handle these, whatever the softwares are required, and those are developed by these students and be considered as internships. Internship for the other related projects also are provided by the ITB. Training to the student to be ready to tackle any kind of internship and project to strive for their progress. This is the main motive of this forum. Some achievement, 100 placement pay for the student from our colleges. Those are from these forums. Being the part of this forum, it gives a massive advantage to the student over the other applicant. It inculcates confidence and striking personality traits which are favorable to the recruiters. That's the biggest takeaway from this forum. Student projects, they are developing a wonderful project. I have a YouTube link, you can find out. They are excellent multidisciplinary projects. Students from computer, ENTC, mechanical, electrical, all are combining to work on a particular project and creating a nice, intelligent product, okay, which includes all the disciplines. Many of the students has published international journal papers at this undergraduate level. This is one of the biggest achievement by these students. 6 students successfully completed internship. 11 students from PVG contributed for VLab outreach portal. So outreach portal, what you are seeing, that has been developed by our students. 3 students delivered session on mind maps. So many of our students are working as speakers in various boot camps. 5 students received platinum certification for completing their virtual lab. Shubham and Harshada, presently they are in this session. They are one of them. 8 virtual labs have been developed by the students under the mentorship of various faculty. In all, 40 plus students are recognized as a virtual lab developer from our college. Various teams has participated at various boot camps and bootathon, and they have achieved the various success rates. Many of them are certified as a developer in various programming languages by IIT Bombay. Many projects, they have delivered various kinds of projects from IEEE and various industries, and they are developing on apps on Google Play Store. highest packages is offered to the student of this forum. Yeah, finally, I would like to say about this is my team, and this is a big and massive team consisting of 148 plus students and 14 faculties. And that is why this massive team itself responsible for achieving such a high milestone. So I thank all these team members from my side being a part of this and having a great journey. Yeah, thank you. I hope you have enjoyed my presentation. Over to you, Minal ma'am.
Thank you, Nagosha sir. Now we are coming to the conclusion session, but before that uh, we have a session from Pushpadeep Mishra sir. Over to you, Bhalke sir, for his introduction.
Okay, madam. Nole, madam.
Yes, yeah. Yes, I'm there.
Yes, okay.
Okay. After interactive hands-on on virtual labs, I welcome you all for the valedictory program. For this program, we have with us Pushpadeep Mishra sir. I take an opportunity to introduce Pushpadeep Mishra sir. He currently works as a project manager with VLabs IIT Bombay, and in this context has played a key role in outreach development and community engagement for VLabs. He believes in working at the grassroots level. This mainly involves interacting with students and teachers and identifying problems and challenges faced in the academic settings. His focus has been on working out optimal solutions for rollout and content development for VLabs. His other area of interest are grid computing, bioinformatics, and drug discovery. He believes in community power. Together, everyone achieves more. We welcome you, sir, for the session, and I request you to take over the session.
Yeah, good afternoon. Just trying to test my microphone. Am I audible?
Yes, sir, you are audible.
Okay, I am briefly starting my camera because I have a weaker connection. Am I still audible to you?
Yes, sir. Yes. You are audible.
Okay, very good evening to all of you. Yeah, and at the very first, I would like to thank to all the dignitaries who began the session in the morning. Dignitaries from Pune University, from AISSMS College of Engineering, from PVG's College of Engineering and Technology, all the students, all the presenters, all the nodal coordinators, and all dear fellow faculties who have attended this session right from morning. And till now, I see that there are more than 1,500 faculties who are still joined, hooked to us via Zoom and yeah, YouTube. And thanks all for joining in. Well, a lot of things have been covered already since the start of the session. And by now, I think everybody has a very good picture of the virtual lab. The orientation has been done very well. Well, let me tell you that uh, we with the physical sessions, in fact, we could never address such a large audience. And well, I must say that looking at the optimistic side of the pandemic, which has which has actually not left even my home. So even we are quarantined. We have a family member who is in hospital right now. But anyways, looking at the flip side, since the conference is virtual now, we could address more than 1,500 participants in one go. And this is the advantage of the technology. And we should try to take optimum, we should utilize it up to the maximum. Virtual labs, and therefore in this time of distress, have been helpful to millions of students, not just in our country, but all over. And faculties have also been taking benefit out of it. And I believe after the such an exhaustive session with an extensive outreach which has been conducted today, even you would have got a flavor of, yes, I would say flavor of, because I mean, we have PVG, AISSMS, and all the other nodal centers who are hooked to us, linked to us since 2015. and they are still exploring the avenues in virtual labs. So I must say that today what you have got is just the flavor of what you can what you can get by using and developing virtual labs. Well, I think you have spent a lot of time today, and most of you must have been exhausted. And so I would just like to take very few minutes of yours, and would like to share some stories rather. Just to have the end very relaxing. I know you have been a lot of stress, possibly using your laptop in front of screen. So I would just like to share some stories of virtual labs. So, well, Virtual Labs project, it began in 2009 as a pilot, and then since then, um, it was developed. Few experiments were developed by IITs, and then later on, when it was well received, by 2011 we had more than 50, 60 virtual labs available. By 2014, there were more than 1,400 experiments were created. Now, with the massive content creation, which MHRD has helped to us and all the IITs, we are the partnering institutes. Uh, then moment started for rolling out the content, because we have created content for the student communities, for the academic communities, and you are the beneficiaries of the project. So, uh, I mean, it was a big challenge. We are uh, we are a country with a very big population, and how do we reach to the grassroots? It was a major challenge that was in front of us. I mean, today most of us have a very good smartphones. Everybody, in fact, uses the technology, although there are still some gaps in remote areas. Way back in 2014, it was a little bit different. Not everybody had access to very good bandwidth. It was still 3G networks. Uh, it was challenging to reach out to people. And in that time, during those times, we actually started a rollout, and we kind of physically moved from city to city, village to village, going in routes of Maharashtra. And by end of 2015, we had around 20 nodal centers, and PVG was the one of them. And the experience was just started to begin, and after some in 2016, the existing 20 centers took virtual labs very well, and then we also tied up with AISSMS and the other colleges in Pune, uh, colleges in Gujarat, uh, and at present we have around more than 160 nodal centers. So in last 5 years, we although but IIT Bombay was supposed to look at the West, uh, much of the network is deeply rooted in and around Pune, in colleges around Gujarat as well. And now recently we have interest which has been coming up from Jammu and Kashmir and Jharkhand. So, well, uh, why I'm talking about outreach and why this all event has been held for you? Why outreach is very important. Uh, well, I'm getting a message that my internet connection is weak. I'll stop my webcam. Just a second. Yeah. So why it was very important. Well, let me tell you. First, in fact, let me thank all the presenters, all the resource person who took so much effort in holding this event. Uh, as I mentioned, the end beneficiaries are all the student and faculties. Now, suddenly, what has happened is that due to cutoff from the physical lab environment, everybody seeks an alternative route for experimentation. Well, virtual labs were never meant to replace the physical education, as Professor Nagoshe in his talk mentioned recently, a few minutes back. So our intention still is not to replace the physical lab, but to build confidence, to build, give an exposure to the students who cannot reach to the physical labs. Well, therefore, it was very important for us to hold such an event where we can explain, we can take you on a tour, holding your hands in a virtual mode and trying to give you an experience of what virtual lab using virtual lab is like. And therefore outreach is very important, because when we were conducting a physical session, if we just went into a classroom and or you just text your students that this is virtual lab, it doesn't work that way. You have to there's something called as training which is involved into the student to the students and the faculties. So it is very important to conduct outreach workshops, to do in-house. So once you become a nodal center, so after this event, after this once we are concluding, after we conclude, you can approach the organizers. You can mail us if you're interested to become nodal centers. So once you become nodal centers, you also need to conduct the in-house sessions. You have to plan your semester. You have to include virtual labs in your semester curriculum, and you have to conduct such sessions along with the students. And let me tell you, you will find a remarkable difference between the in the performance before and after the virtual labs. And this is what I have heard from all the speakers who have been giving their talks since morning. So I do remember the interaction with, when I was in Pune sometime back with Dr. Bormane, and the way he has taken virtual labs at AISSMS, and because of all the efforts, the event could be organized. So what does this outreach model tells us? See, it's like building a network of colleges, and not just helping your students, but trying to understand the academic ecosystem, trying to understand what your academic community needs. So this event, most of you are coming from Pune University, but even if you are from some other university who are attending the event, understand the need of your academic environment. Okay, and I must appreciate the conglomeration of these two colleges who are holding such a massive event for Pune University, that it requires a vision. It requires a vision. I think they have taken this into the mission mode, where they are determined to help the fellow faculties, fellow colleges of Pune University to ensure that they get the maximum benefit. You get the maximum benefit of virtual labs, and also trying to fill the syllabus gap. So yes, outreach workshops are very important, therefore, so that you get everybody gets an exposure. Now, as I mentioned, when you conduct workshops, say in-house, not just between the colleges, it is when you enroll for virtual labs as a nodal center, you also build internal community, because as Professor Nagoshe mentioned a few minutes earlier, that um, having a culture of interdisciplinary, or say multidisciplinary approach, is very important in the academic setup. Because when students, they graduate and they enter the real world scenario, they never find their own subject in isolation. I mean, it's like everything is mixed. Even a car that goes on the road, if they are working in a manufacturing company, there are so many different forces, there are so many different disciplines that come into picture, say chemical engineering, electrical engineering, computer engineering, everything. So of course, we are not saying that everybody should be master of everything, but then having the knowledge of how things work in pollution will definitely help the students to understand the concept even better. Because at the end, application of the knowledge is very important, and therefore building a community within your institute. With the large photograph of the virtual labs community that you saw some time back, I think that clearly states that having a united approach, not just towards virtual lab, but towards the routine teaching learning, is very important. We should not see departments as, of course, there should be healthy competition between departments, but then it should work in synchrony. That is very important, and this is what we believe in virtual labs community. Now, talking about the second aspect of the project. So I just mentioned about the rolling out the content through outreach and in-house workshops. Uh, so way back in 2014, we had only IITs been developing the content, and and slowly, I mean, we could see that there was a lot of energy in amongst people, and especially when I visited PVG. I mean, see what happens is that once you do a very good outreach, very good in-house workshops, you submit your data on outreach portal. We understand that how enthusiastically you are taking the project ahead. And because of these reasons, we had a very good interaction, regular interaction with PVG, because we saw that their usage, I mean, the mandate was 5,000. So they did 8,000. The mandate was 8,000, they did 12,000. So even with the AISSMS and college and with some other champions in Pune as well. So a lot of institutes have done very well, and this gives an opportunity to interact with you. So therefore, doing an outreach, very good outreach and rollout is very important. And therefore, I mean, it came from the community, it came from the colleges. So the proposal came from Professor Nagoshe Kataukar madam to develop virtual labs. And they started with a proof of concept, and which we showcased to MHRD. And it was said, okay, fine, let virtual labs, nodal centers be given an opportunity. And then we took a very strong approach towards the community. Uh, After PVG, just like today's workshop, they held many other workshops. We also held boot camps and other events. Through this, the network really increased, and we formed a different. I'm going to just broadcast my screen. So through this, we have a strong team of say faculties and students. We call them as faculty leaders. You can see faculties from say Gujarat University, Baroda, from Aurangabad, and a team from PVG, and we have student leaders from several other some from colleges in Pune, and of course at several other locations. So a community has started to build up, and you can see this site, VLabs Dev. So VLabs Dev is a community face of virtual labs, and it stands independent. It is completely led by the community.
Sir,
It
are you
is
showing,
completely led by the community,
sir,
and
sorry to disturb you. Sir, are you showing some website?
yeah, yeah.
So that is not visible, sir.
Okay, 1 minute. Let me try to stop share, and as we start sharing. Is this visible now?
Yes.
Okay. So yeah, I was talking about this virtual labs team. So VLabs Dev is a community wing, which is completely. So this website itself is made by the community champions, by the contributors. So you can see they all are leading from different. So virtual labs community is now going very strong, and I'll tell you, I remember my days from Pune, traveling to Pune. So you take a train from Mumbai, and you actually, while you're going and crossing towards the Khandala and Lonavala Ghats. So when there is an interchange at midpoint, you have three engines which actually which pull the train towards the uphill, and there's just one engine which is at the back, just in case a push is required. It's always there to support. So exactly, we are playing the same role. So uh, these are the front engines actually, which are actually carrying the project ahead, and we are just at the one single engine at the back, which are we are always there if a push is required. So the entire team, entire effort is led by the community, and this is what we could successfully demonstrate that with power of community, you can achieve really more. And if you have got talent, if you can really showcase leadership into rolling out virtual labs, into content development, then you are just part of the community. And there are more people who are going to join this board. We recently had content development events, and almost half a dozen of more people are going to join this dashboard. When you check next week, so So with this, I have touched upon the community and content development. Uh, just spending another couple of minutes on the content development, and then I will conclude. So this chart you have seen several times since morning. This is I've pulled it off from Professor Narona's slide. So you can see what is our objective. I mean, we have been talking about virtual labs since morning, right? We are you have used virtual labs by now, and you have listened to from so many resource persons. So what is the end goal? End goal is to enhance the quality of education, and that is what is very important. And therefore, I mean, this Bloom's taxonomy, I'm 10% sure is not new for you, but let me tell you, I've been traveling across the country. I've been going to several states. I've been meeting so many colleges and faculties. But let me tell you, still the concept of Bloom's taxonomy is not very clear to many of them in terms of lab practicals. Okay, so Bloom's taxonomy have been talked a number of times. When we listen to Khan Academy, you listen to say Byju's, or you listen to NPTEL, or you listen to any of the Coursera, Udemy, any of the courseworks. But then when you ask how you implement this Bloom's taxonomy for virtual labs, or say even for your actual lab, it's very challenging. Not everybody can correlate. This is where the problem is. Theory content, it's very easy to grasp, it's very, or probably it's sometimes easy to understand, but then practical approach of it, and how do you go to the top three levels of the pyramid? This is what our objective is. We have to take our students. I think today we should all pledge, we all 1500 of us who are there in the event, we should all pledge, all the faculty should pledge that we should try our best and ensure that we take our students to about two levels, say evaluate and create. These are the apex levels of Bloom's taxonomy, where the students are as you've seen in Professor Nagu's slide. I mean, there was a computer chip and RAM. So let students, the top two levels, let students mind work. And therefore, when we talk about quality education, only when you can strike that thought process in the student's mind, then you can say that your job is done as a faculty. So this is very important. Mark this picture in your mind, and this is what we should try achieving. And so I once again request all of you to continue using virtual labs. I think it's a need of the hour, and also to once you have utilized it very well, aim towards content development. And let me tell you, all the boot camps and everything that we have been talking about, all our time goes into training faculties on how to go till this top two level. This is very challenging. If it was very easy, it wouldn't be that creative, correct? So it goes like that. So it has to be, a lot of effort goes into creating content which addresses top two levels of this Bloom's taxonomy. It is very challenging, and let me tell you, the champion faculties, I believe all of you are champion here. Uh, it's a challenge for you, and we throw open this challenge to all of you to develop content. We have created 1400 experiments so far, and there are more than, I believe we have more than 3000 experiments yet to be created. Let me tell you, 3000 experiments are yet to be created. We have done the syllabus mapping. Only 1400 experiments are there. So roughly around 4 to 5000 experiments should exist pan India. Okay, that too I'm talking about some common syllabus of 5 universities only. uh, you should try to do this exercise for your university, and try to get an estimate of it. There's a lot of things to be done, a lot of content has to be created. But yes, first you can appreciate, you can create content only once you understand how to use the content. So be a part of virtual labs and start using content, and then we'll definitely help you out to create the content. Yeah. So some last takeaways. Yeah. So So therefore, and with this approach, so as I mentioned that we are mainly responsible towards West India, and because of this community approach, people even from nodal centers, the colleges even from the northeast part of the country have joined us, and the community is growing, and we are just waiting for you to join us and contribute. With that, I thank all the faculty. Thanks for attending. Thanks for coming on the event. Thanks to all the organizers, and I wish you.
Thank you so much, Pushpadeep sir.
Thank you, sir. Thank you, Pushpadeep sir, for sharing your experience on VLab and the way it is going to benefit students and will make them understand the concept by performing experiments on VLab. And yes, it is going to benefit students even in their project and enhance the quality of education. We are very thankful to you, sir, Pushpadeep sir. Now let us move to feedback. Now may I request Dr. Lahudkar sir, member BOS ENTC, to please share his feedback.
Sir, you can unmute yourself.
Yeah. Good evening. Good evening. Can I audible, sir?
Yes, sir. Yes, sir.
Yeah. Very good evening to all the dignitaries, organizers, and dear fellow participants. Myself, Dr. Lahudkar, working as a professor from JSPM's Imperial College of Engineering and Research. At the outset, let me congratulate Dr. Bhalke sir and his team from AISSMS College of Engineering, and also Khataukar madam and her team from PVG's College of Engineering and Technology for having a wonderful workshop of providing the hands-on demonstration on few of the experiments on virtual lab from IIT Bombay. Working with virtual labs is need of the hour, as this pandemic of COVID-19 has taught all of us how important is the online aspect of teaching and learning in coming years and in near future. Also, as per the mandates from AICT, we are supposed to go with 20 to 25% of content delivery, which includes online conduction of theory as well as practicals. Moreover, conducting and performing such practicals and practicals on virtual lab create lot of interest, awareness, and understanding for the subject among the learners, which are today, I must admit, they are very advanced and smart. This one-day workshop has focused the utilities of virtual lab not only in one particular discipline of engineering, rather it has focused all the disciplines of engineering, including engineering sciences. Also, there was one session from Kalshetty ma'am from humanities discipline on business communication as well. So I appeal to all the fellow participants to explore more and more experiments on virtual lab setup, and also develop certain experiments in near future, which will, as rightly explained by Khataukar madam, will be an important achievement for the institute, faculty, and the students involving in developing the content. I would like to share one more information at this particular platform, that just 2 days back itself, our institute, that is JSPM's Imperial College of Engineering and Research, got the Nodal Center from Virtual Labs IIT Bombay, for which I thank from bottom of my heart to Khataukar madam for extending the cooperation in getting the center. Thank you very much. Finally, once again, I congratulate all the organizers and for excellent and flawless execution of the workshop, and also thank them for giving me the opportunity to express my views. Thank you so much. Over to you, sir.
Thank you, sir. Thank you for sharing your valuable feedback with us. Now, may I request Dr. Manoj Nagmode, sir, from Avsari College of Engineering, to share his feedback.
Nagmode sir, you can unmute yourself. You are a co-host now. Nagmode sir. Hello.
He has unmuted.
Nagmode sir.
Hello, Nagmode sir.
Okay, you can ask some other participant to give feedback if they are
Madam,
interested.
Navle madam, you can
Yes,
call
sir.
Pradam madam, MA Pradam madam.
Okay. Now, may I request Dr. Mrs. Pradhan ma'am from AISSMS College of Engineering. Ma'am, can you share your valuable feedback?
She is also not there. May I ask Devendra Bhuyar sir? Devendra Bhuyar sir, you can unmute yourself and give your feedback, please. Devendra Bhuyar sir from Aurangabad.
Good evening, sir.
Yeah, Nagmode sir is there. Okay. Yes, sir. Yes, sir. Nagmode sir, you can proceed.
Hello, sir. I think Bhuyar sir is speaking.
Nagmode sir is there. Nagmode sir, can you get my voice?
Okay, I think Bhuyar sir is ready.
Bhuyar
You
sir,
can
yes,
ask.
sir. Bhuyar sir, please
Please,
go
you
ahead.
can proceed.
Hello, good evening, sir.
Good evening, sir. Please, you can proceed.
Yes, sir. Thank you very much for organizing this virtual lab event. As today is the need of that all departments, you have covered all PVG college and AISSM college covered all the departments lab near about which is available in IIT Bombay. And I also, our CSMSS college is also nodal center for the virtual lab. We are also trying to develop some lab as already we are in contact with Pushpadeep Mishra sir. So that time also in Marathwada region under the nodal regional center of MIT Aurangabad, we are doing this work. And today's sessions from starting from morning, we are very much thankful to for this region because hands-on is not possible. Theoretical lectures, theory lectures we can do with the help of for online teaching, but hands-on is very important. So we have given the focus on online hands-on. So thank you very much for this arranging the very good manner. From my side, we are also doing under the guidance of Dr. Ullas Shinde sir. So definitely we will do the develop some lab from our college also. Thank you very much, sir, for giving an opportunity to share my view. Thank you very much, sir. Thank you.
Thank you, sir. Thank you for sharing your feedback. Now, may I request Dr. D.G. Bhalke, sir, HOD ENTC Department and VLab Nodal Coordinator, AISSMS COE, to present overview of today's event.
Okay, thank you, madam. Today was a very exhaustive session for all participants. I think more than 2,000 participants have participated into one-day workshop on this outreach activity on the VLab activity. This is being organized by PVG College of Engineering and AISSMS College of Engineering. As Pushpadeep Mishra sir, who is a project manager of this virtual lab, and Professor Narona Santosh, who is a principal investigator. So both they have talked about the enhancing the quality of the education. So now if you look at a scenario of the education, so the students are not becoming more employable. So definitely there is a big gap in the industry and the institute. As you look, the government is also focusing on outcome-based education. And if you look at different cognitive level of the student, like mostly they're using remembering, understanding, and the applying taxonomies. But again, as everyone were talking about the higher cognitive level ability of the student, unless until the student develop their higher cognitive level ability, they could not able to perform better in the society. So that is using the cognitive taxonomies like the analysis, the evaluation, and the creativity. So definitely that would not be possible to attain these taxonomies through our curriculum. So they will be attained through the different co-curricular and the extracurricular activities. And definitely this virtual lab provide a great opportunity for all students as well as a faculty member to attain higher level of taxonomies. And this, as Nagoshi sir also spoke about, that a virtual lab focus on the interdisciplinary, on the multidisciplinary approach. So this interdisciplinary and the multidisciplinary approach is possible through this virtual lab. As Pushpadeep Mishra sir always he was talking about the community engagement, because that is one of the most important thing which is required for the student, because our basic purpose of the education is to provide the service to the society, and that is possible through the communication engagement. Even our students are lacking with innovation and the creativity, they are lacking with the communication skills, they are lacking with the skill-based education, so which makes them unemployable. And I think all these issues are addressed by this particular virtual lab project, which is initiated by MHRD Government of India, and I think IIT Mumbai team, Narona sir, as well as the Pushpadeep Mishra sir, they could able to reach so all part of the society across the India. So definitely this is a great opportunity for everyone to make our student employable, to reduce the gap between the industry. Even every colleges nowadays are thinking for the accreditation. So if you look at their accreditation parameter, so those accreditation parameters are based on the outcome-based education system. So definitely this will help for student, not only for the outcome-based education point of view, or from the skill point of view, they will help them more employable, so that with the help of this.
Hello, sir.
They appealed to make use of the technology. Then Narona sir also explained about all the virtual lab project. Then our Dean Science and Technology, Manohar Chaskar sir was there. Then Bormane sir already he has taken initiative in the Board of Studies Electronics. Already he has introduced the virtual lab experiment. Then Dr. Khaduskar also he has briefed about the project undertaken by the PVG College of Engineering. Then all team of PVG College of Engineering, including Khataukar madam, then Minal Apsange madam, Priya Deshpande madam, Aditya Kumar Dongre, Urmila Kalshetti, then Kasma Bhalbude madam, then Nagoshi sir. So everyone have explained very well. I think the major takeaways in a summary of this today's workshop are, that is the colleges can start their nodal center, they can carry out the outreach activities, and they can reach to all part of the society. They could motivate student to develop virtual lab. The faculty and the student can also be involved into this. Then they can just motivate student for the skill-based education, and overall the purpose of the education is a better learning of the student. Definitely better learning of the student will happen. I really congratulate the IIT Mumbai team, PVG team, and all AISSMS team for taking this project out as the society, which will benefit all part of the society, and they will fulfill our aim and objectives. With this, I conclude my today's the workshop details. Thank you very much.
Thank you, sir. And truly, this is going to enhance the quality of education. Now, may I request Professor N.P. Maure, sir, ENTC Department, AISSMS COE, to present a vote of thanks for this event.
Just a minute. Good evening all. I'm here just as a last part of this session. After this session, which will have only one part, that is photo session, and then we'll end up the workshop. So today I'm here to propose a vote of thanks on the behalf of PVG College as well as on the behalf of AISSMS College of Engineering, I am proposing this vote of thanks. First of all, Miss, I am very much thankful to our management of AISSMS, Sri Shahu Chhatrapati Maharaj, President AISSMS Society, Sri Sambhaji Raje Chhatrapati, Vice President AISSMS Society, and Sri Maloi Raje Chhatrapati, Honorary Secretary AISSMS Society, Pune, and other management members for their support, motivation, and inspiration to organize such type of event. I'm also very much thankful to our today's guest, chief guest, Dr. Nitin R. Karmalkar sir, Honorable Vice Chancellor, Savitribai Phule Pune University, for his time and motivation, and whatever the guidelines here given. So definitely our faculty member will do that. I am also thankful to guest of honor, Dr. Manohar Chaskar sir, Honorable Dean, Faculty of Science and Engineering, Savitribai Phule Pune University, for his time also. I'm also thankful to all our speakers, Dr. Santosh Narona, Honorable Principal Investigator, Virtual Lab, IIT Bombay, Dr. D.S. Bormane, Honorable Principal AISSMS CV Pune, and Chairman Board of Studies, ENTC, for his guidance, support, and inspiration. And I am also thankful to Professor Rajendra Kauskar sir, Honorable Director PVG's CUT Pune, for his guidance, motivation, and support. I'm also thankful to both speakers, keynote speakers from VLabs IIT Bombay for this, and especially Honorable Pushpadeep Mishra sir, Project Manager, Virtual Labs, IIT Bombay, for his nicely briefing about our VLabs at national level, and so on, how we can go for the Nodal Center. I'm also thankful to all the organizers. First one, the PVG COT VLabs Regional Nodal Center. Then second one is AISSMS College of Engineering VLab Nodal Center. So in coordination with Savitribai Phule Pune University, SPPU, BOS Studies, ENTC, and the Virtual Lab IIT Bombay for their support for organizing this event. I'm also thankful to all the motivators from AISSMS and PVG, Dr. D.S. Bormane sir, Principal AISSMS COE, Professor Rajendra Kauskar sir, Director PVG, COET Pune, and Dr. K.J. Kulkarni ma'am, In-charge Principal PVG COET Pune, for their motivation to all the team members. I'm also thankful to all the speakers for this one-day hands-on workshop. Tanuja Katagur madam, Manish Nagoshi sir, Dr. D.G. Balke sir, Meenal Aptangi madam, Urmila Kalshikti madam, Shama Balbudde madam, Ranjita Ghosh madam, Aditya Dongre sir, then Priya Deshpande madam, for their nicely explaining the VLabs as well as the road ahead. Then all the participants from SPPU Pune, engineering institutes, polytechnic colleges, and other institutes. So it is a very, you can say, pride moment to say that or to share that. So we have received near about 3,510 plus participants for this workshop. They have registered and they have attended today. So somehow are attended in a Zoom meeting, and some participants have attended on the YouTube channel. So I'm thankful to all the participants for your the grand participation and patiently listening and performing the VLab experiments, as well as giving the feedback on the, this outreach portal. Thank you very much, all participants. Now again, coming to the regional lab coordinators, I'm also thankful to Professor Tanuja Katagar madam, the Nodal Tech Coordinator, Pune, and Certified VLab Developer for IIT, Virtual Lab IIT Bombay, and Professor Manish Nagoshi sir, so Regional Tech Coordinator, Pune. I'm also thankful to nodal coordinators from both the institutes, Dr. D.G. Bhalke sir, he's in this HOD, ANTC, and a nodal coordinator AISSMS Pune, and Professor Meenal Apsangi, nodal coordinator and certified VLab developer, Virtual Labs IIT Bombay, from PVG CUT Pune. I'm also thankful to the workshop coordinators, including myself and Professor Urmila Kalshetty, Nodal Tech Coordinator, PVG CUT Pune, for smooth as well as the nice implementation of this one-day workshop. Thank you very much. I'm also thankful to the anchors of today's session, Professor Vaishnavi Navale Madam, AISSMS College of Engineering Pune, and Professor Neenal Apsange Madam, PVG College of Engineering and Technology Pune, for their support as well as the nice execution of this event. Thank you very much, both of you. I am also thankful to organizing team members, other organizing team members from AISSMS College of Engineering Pune, so especially Department of ENTC faculty members and PVG COT Pune team for their smooth organization of this event. Thank you all organizing team members. This event was held on Zoom as well as YouTube, live YouTube. So this was hosted by me. So, and I am also thankful to our flyer designers, Miss Shreya Gorte from BENTC College of, AISSMS College of Engineering Pune, and Miss Swar Malu, BENTC AISSMS College of Engineering Pune, for their support and nicely designing all the flyers. So it looks very good, as well as they have done the branding in a large level. Thank you very much. And last but not least, all the student coordinators from AISSMS College of Engineering Pune and PVG College of Engineering and Technology Pune. From AISSMS, Ms. Shreya Gote and Maluswar, and from PVG, Ms. Shreya Gore and Harshada Gundecha, and all other student members for their help as well as support to make this event a grand success. And thank you all for your patience listening and all. So stay home, stay safe. Jai Hind. So this is the end of this event is with authority. So I'm just requesting.
1 minute. 1 minute,
Yes,
I will speak. So on behalf of both the colleges, I also extend my hearty thanks to Professor Nitin Mawale sir, who is taking endless support for hosting the Zoom, coordinating the event, coordinating all flyers and everything. Also, the success of the credit, success of this workshop goes to Nitin Mawale sir. We are also very much thankful on behalf of both the team as well as IIT Bombay sir.
Thank you very much, sir. So, with the authority permission, Miss, I conclude that this workshop is over. But before leaving, Miss, we will have one photo session. So, may I request all the participants to start their video so that we can have the selfie with the speakers as well as the members. So, all the participants, please start your video. So, it will take only 2-3 minutes. I will start my video also. So please smile. Total 16 screens are there, so wait for 1 or 2 minutes. So I'm just capturing the photographs. It's really a very, I can say from the bottom of heart, I'm really very much thankful to all the participants for such a patience listening. Attendance link will be, attendance of second session will be shared after this photo session on a YouTube channel as well as again on the Zoom platform. Many participants have not started their video. Please, I'm requesting all to start your video so that there will be a memory for us along with your photograph. Please start your video. I request Nagose sir to share the feedback link sorry, attendance link in the chat box.
Yeah, sure. Urmila ma'am, are you there?
Sir, it is already shared, sir. In the chat box of Zoom, it is already shared the link.
Thank you, madam. So thank you very much, all the participants. Hopefully, means all this memory we will share with you on your this registered email ID. So before leaving again, I'm just asking all to give the attendance of all the sessions, these 2 sessions, and you will get the certificate uh, within 8 days after confirming whether you have given the outreach feedback or not. So as discussed earlier, you have to give that outreach feedback of at least 2 assignments, 2 practical assignments on a outreach portal. So I have again inserted the attendance link on a YouTube channel. All YouTube channels participants can fill this attendance. And I am also thankful to all the YouTube participants. So they have also waited till the end. So thank you very much, all YouTube participants. Thank you.
Those who have not submitted feedback on that outreach portal, they can submit by today also. Up to 12 p.m. you can also submit.
Sir, please request them to just fill the feedback only by today. Tomorrow that link will be closed.
Yeah. By today only you have to submit the feedback. Unless until you submit at least feedback up to experiment, then it is difficult for us to issue the certificates. So please kindly take a note of this. This is a technical issue, so you have to submit feedback. So thank you for all participants for your patient listening and active participation into hands-on workshop on virtual lab. Now I think with permission of Chair Pushpadip Mishra sir, we will end this Zoom meeting. Shall we end meeting, sir? Are you there?
Yes, sir. Just we'll wait for another 5 minutes so that
for feedback.
YouTube,
Okay.
YouTube participant will fill that and we'll end the meeting.
Okay, sir.
So those who have filled the feedback, they can leave the meeting. Thank you very much all. Those who have filled the attendance as well as the outreach feedback, they can leave the meeting. Again, I have pasted the attendance link in YouTube channel chat. Fill your attendance for session 2. Again, as per the instructions by regional center, you have to fill this both attendance as well as you have to give your feedback on our outreach portal by today only. So tomorrow it will not be considered. So kindly take a note of this. Those who have completed the attendance for second session, so the participant from Zoom as well as participant from YouTube, you can leave the meeting. Thank you very much.
Bombay sir, thank you so much for all your support.
Thank you, madam. Thank you very much.
Balke sir, Mawale sir, good coordination. Thank you very much.
Thank you, sir. Thank you very much. Thank you very much, all participants. I hope Miss everybody has filled the feedback as well as the attendance for both the session. Again, I am repeating. So you have to fill the attendance of both sessions, then feedback for at least 2 assignments, and that too again today only. So otherwise means the certification for you will not be provided. Which if you are not filling those feedback of at least 2 assignments today on our outreach portal of IIT Mumbai. Thank you very much. And now today I'm in just now I'm ending this meeting. So thank you very much. So hopefully means we'll see you soon in our next coming webinars. Thank you very much.